The real secret behind America's unstoppable World War II weapons wasn't just steel, gunpowder, or clever engineering. It was scale and the calm, relentless ability to build the same good weapon again and again until the outcome of war became almost inevitable. Welcome, my friend. I'm glad you're here tonight. Get comfortable, settle in, and let your breathing slow down as we ease into a quiet, factual story from the Second World War. Before we begin, I'd love it if you left a gentle little comment telling me where you're watching from and what time it is for you right now while you're listening. I always enjoy reading those, and it helps this sleepy history community feel a little more connected across the world. Now, tonight we're exploring a simple but fascinating question. Why did America's weapons in World War II become so effective, so widespread, and in so many ways unstoppable? Not because they were perfect, not because they were magical, but because they were designed, produced, supplied, repaired, and improved with a kind of quiet momentum that's hard to fully appreciate unless you slow down and really look at the machine behind the machine. So let's start at the beginning, with the most important weapon of all, one you can't hold in your hands, but one that decided enormous parts of the war: the industrial scale of the United States. When people think about weapons in World War II, they often picture a single iconic object: a rifle in a soldier's hands, a tank rumbling across a road, a bomber droning high overhead, a battleship sliding through the dark ocean. And yes, those objects mattered. They mattered deeply. But what mattered even more, and what made American weapons feel unstoppable to friend and foe alike, was something quieter and far more powerful. The United States was able to make war into an industrial process, and then make that industrial process repeatable, steady, and unbelievably large. In other words, America did not simply invent weapons. It created a system that could build weapons, deliver them, maintain them, and replace them continuously at a pace that reshaped the mathematics of the conflict. World War II was not the first industrial war, of course. The First World War had already introduced the world to mechanized slaughter and mass production on a terrifying scale. But the Second World War expanded those industrial demands even further. The battlefield widened to entire continents and oceans. Armies moved farther and faster. Aircraft became decisive. Naval power became global. And the amount of material required: steel, aluminum, copper, rubber, oil, food, ammunition, grew into numbers that could sound almost unreal. In that world, the weapon was not only the gun. The weapon was the factory. The weapon was the railroad. The weapon was the shipyard. The weapon was the supply depot. The weapon was the ability to coordinate millions of workers, tens of thousands of machines, and endless streams of raw materials into finished products that could reach the front lines. This is the part of the story that often stays in the background. It's not as dramatic as a battlefield scene. It doesn't have the instant emotional hook of a heroic charge or a desperate defense. But if we're asking why American weapons became unstoppable, this is where we have to begin. Because the American advantage in World War II was not simply that it had good weapons. It had the capacity to turn good weapons into a flood. And importantly, it didn't need to flood the war with only one kind of weapon. It could flood the war with everything at once: trucks, rifles, artillery shells, landing craft, locomotives, fuel, spare parts, radios, bandages, uniforms, aircraft engines, and the 1,000 other items that modern war requires. Now, to understand why the United States could do this, it helps to step back before the war even begins. The United States in the 1930s was in the grip of the Great Depression. And yet even in those hard years, it remained one of the world's great industrial powers. The American economy was enormous. Its natural resources were extensive. It had large deposits of coal and iron. It had oil fields that were producing at a scale unmatched by most other nations. It had wide open land, major rivers, and a transportation infrastructure that stitched the country together. Most importantly, it had a huge base of industrial knowledge already developed over decades. Automotive plants, steel mills, machine tool production, electrical manufacturing, chemical industries. Even when times were difficult, that industrial foundation remained. It could be underused, it could be slowed down, but it still existed, waiting to be awakened and redirected. When war came, that redirection happened with a force that still stands out in history. One of the most famous phrases associated with American production in World War II is the arsenal of democracy, a phrase used by President Franklin D. Roosevelt. It was an idea as much as it was a description. America, protected by oceans, was not initially fighting a ground war in Europe, but it could produce weapons for those who were fighting, and later it could produce weapons for itself at scale. This concept mattered. It positioned industrial output as a moral and strategic necessity, and it encouraged a kind of national mobilization not just of soldiers, but of workers, engineers, planners, and factory owners. But the real story of American industrial scale is not simply a slogan. It's the details, how production was organized, how factories were converted, how standardization was enforced, and how logistical thinking guided the entire effort. War production in the United States did not happen by accident. It involved government agencies, private companies, military planners, and labor forces working within a framework that combined urgency with structure. One key player in this was the War Production Board, created in 1942, which helped coordinate the allocation of raw materials, the prioritization of projects, and the conversion of civilian industries into wartime production. There were also other agencies and programs, all aimed at one central challenge: taking a country designed for consumer goods and peacetime commerce and transforming it into a nation capable of producing the equipment of global war. The United States had a unique advantage here. It already had a culture of mass production. Before the war, American industry had mastered assembly line methods at a level that was still impressive by world standards. The automotive industry, especially, had refined the art of producing complex machines quickly, using standardized parts, repeatable processes, and specialized tooling. This was not just a technical achievement, it was a way of thinking. Mass production is a mindset as much as it is a set of machines. It involves designing products to be built efficiently. It involves minimizing unnecessary complexity. It involves training workers to do tasks reliably and quickly. And it involves organizing supply chains so that parts arrive exactly when needed in enormous quantities. When the United States began producing wartime equipment, that mindset came with it. Factories that had produced cars, refrigerators, radios, and farm equipment began producing tanks, trucks, aircraft parts, rifles, and artillery shells. In some cases, the conversion was dramatic. A plant that once produced passenger vehicles might be retooled to produce aircraft engines. A factory that once built household appliances might be redirected toward munitions. The scale of this transformation was massive, but it wasn't chaotic. It relied on planning, engineering, and the ability to create new tooling at speed. Now, tooling is one of those quiet words that matters enormously in industrial war. You can have designs on paper, brilliant ideas, and ambitious goals, but without tools, dies, jigs, fixtures, molds, machine tools, you cannot produce a weapon at scale. The United States had a strong machine tool industry, which meant it could build the tools needed to build the weapons. That sounds simple, but it is a huge advantage. Some countries could design advanced weapons, but struggled to produce them in high numbers because they lacked enough machine tools, or because they were bombed, or because their supply chains were limited. The American homeland, largely untouched by enemy bombing, could expand this machine tool capacity over time, increasing output month after month. This is one of the most overlooked parts of the story. Industrial scale is not only about how many weapons you can build, it's about how many factories you can build, how many machines you can create, and how many skilled and semi-skilled workers you can train. And the United States did all of this in parallel. Another crucial advantage was geography. The United States is enormous, and it has long coastlines, major ports, and vast internal transportation networks. Railroads, in particular, were essential. During wartime, railways moved raw materials to factories and moved finished products to ports and military bases. They moved coal to power plants and factories. They moved steel and aluminum and copper. They moved troops. They moved food. The ability to shift material across such a large country efficiently meant that production could be distributed widely. A ship might be built in one region, its engines produced in another, its electronics assembled elsewhere. This distribution made the system resilient. If one facility had an issue, production could continue elsewhere. And because the American homeland was not under direct attack in the way that Britain, Germany, Japan, and the Soviet Union were, American industry could operate with more stability. That stability mattered. It meant fewer disruptions. It meant fewer emergency repairs to bombed-out factories. It meant the workforce could show up day after day, month after month, to steadily increase output. Now, none of this means production was easy. There were shortages, there were bottlenecks, there were labor disputes, there were mistakes. But the defining feature of American war production is that it grew into a rhythm. It became a dependable engine, and once it reached full speed, it became incredibly difficult for opponents to match. Let's take one calm example: aircraft production. Aircraft are complex machines. They require precision parts, engines, instruments, radios, aluminum structures, and reliable manufacturing processes. In the early years of the war, producing aircraft at scale was a challenge for every nation involved. But the United States expanded aircraft production to astonishing levels. Factories became almost like cities. New workers were trained quickly. Women entered the workforce in huge numbers, taking on roles that had previously been restricted or socially discouraged. The cultural image of Rosie the Riveter is often mentioned here, and while it can become simplified into a symbol, it does represent something real. The workforce expanded, diversified, and adapted. People learned new skills. They built aircraft, ships, tanks, and guns with a sense of steady purpose. Now, the emotional tone of this story can easily become triumphant. But we don't need triumph here. We're looking at the mechanics. The calm truth is that war production is like building a second civilization on top of the first. It requires scheduling, organization, and endless attention to details that most people never think about. How many rivets are needed for a bomber? How many bearings for an engine? How much copper wire for radios? How many tires for trucks? How many bolts? How many spare parts? When you multiply those questions by tens of thousands of vehicles and aircraft, the numbers become enormous. The United States learned how to manage these numbers and keep the flow moving. Another key ingredient was the relationship between government and industry. In peacetime, American companies competed, produced consumer goods and made decisions based on profit. In wartime, the government directed priorities, allocated materials, and issued massive contracts. Companies were encouraged or required to produce military equipment. This created a different kind of economy, one focused on output and speed. It also created a situation where companies could scale quickly because they had guaranteed demand and government support. But the government didn't build everything itself. It relied heavily on private industry, which meant it could leverage existing expertise and industrial organization. This partnership wasn't always smooth, but it was effective. It's part of why American weapons became unstoppable. The system that produced them was flexible and responsive. If a design needed changes, changes could be implemented. If a bottleneck was identified, resources could be allocated. If production needed to expand, new facilities could be built. In some cases, American production went beyond what was required for its own forces. Lend-Lease meant that enormous quantities of weapons and supplies were sent to allies, especially the Soviet Union and Britain. Trucks, locomotives, food, raw materials, and weapons crossed oceans in convoys. This meant American production was not only sustaining American armies, it was sustaining entire coalitions. And that, in turn, meant American industrial scale had strategic effects far beyond any single battlefield. If you want to understand the feeling of unstoppable, imagine being an Axis planner watching ship after ship arrive with fresh equipment, while facing increasing shortages of fuel, raw materials, and replacement parts. Imagine trying to win a war of machines against a country that could outproduce you in nearly every category. It creates a kind of inevitability, slow, quiet, relentless. The interesting part is that American weapons were often not the most advanced in purely technical terms. Germany, for example, produced certain weapons that were sophisticated and sometimes superior in specific ways. Tanks with thicker armor, aircraft with advanced designs, rockets, and jet technology. Japan produced skilled aircraft early in the war and had an effective naval aviation doctrine. Yet sophistication is not the same as dominance. In war, a weapon that is slightly less advanced but available in huge numbers and available reliably can be more decisive than a brilliant weapon that is rare, hard to maintain, and difficult to replace. The United States leaned into what it did best, designing equipment that could be produced, repaired, and supplied at scale. That doesn't mean American designers ignored quality. They didn't. It means they balanced quality with manufacturability. And manufacturability is what turns engineering into power. Another factor in industrial scale was energy. Industry runs on energy. Factories need electricity, fuel, and transportation. The United States had abundant access to energy resources, especially oil. Oil is one of those quiet strategic resources that can decide wars. It powers ships, tanks, trucks, aircraft, and the factories that build them. It also powers the entire logistics chain. The United States not only had oil, it had the refining capacity to turn oil into usable fuels and lubricants. This meant it could keep machines running. It could keep production lines moving. It could fuel ships crossing oceans. In contrast, countries with limited access to oil faced constant strategic constraints. When fuel is scarce, training is reduced, movement is limited, and production slows. So the American oil advantage fed directly into the weapon advantage. There is also the psychological and organizational effect of abundance. When you have enough equipment, you can plan operations differently. you can afford to prioritize reliability and steady supply. You can rotate units and repair equipment rather than improvising constantly. It changes doctrine, it changes morale. It changes the entire rhythm of warfare. American commanders could depend on resupply in a way that many opponents could not. And that dependable resupply was not magic, it was the result of industrial scale. Now, to keep our tone calm and reflective, it's worth acknowledging that industrial scale is not inherently good or bad. It is a tool. It is a capability. In wartime, it becomes a source of destruction, yes, but also a source of survival for those threatened by aggression. And in this story, industrial scale is the foundation that made American weapons feel unstoppable. Not unstoppable because they were invincible in each encounter, but unstoppable because the system behind them was too large to halt. Even if a convoy was sunk, another convoy sailed. Even if a tank was destroyed, another rolled off the line. Even if an aircraft was lost, production replaced it. And not just replaced it, eventually replaced it quickly. This is why historians often talk about the production miracle of the United States during World War II. But it wasn't a miracle in the magical sense. It was the result of a mature industrial base, abundant resources, an enormous workforce, and the organizational ability to coordinate those elements. It was also helped by a crucial factor that we shouldn't overlook: time. The United States entered the war later than some countries. It had time to observe, time to prepare, time to expand production before its armies fully engaged on the largest fronts. And once fully engaged, it kept expanding. In some ways, the war became a race between the Axis powers achieving victory before American industrial output could fully mobilize. And once American production hit its stride, that race became harder and harder for them to win. In the next sections later in the script, we'll explore specific weapons, rifles, machine guns, trucks, tanks, aircraft, ships, and we'll see how industrial scale shaped each of them. But for now, as we rest in this first major section, it's enough to hold on to a simple idea. America's most important World War II weapon wasn't a single gun or tank. It was the calm, endless, repeatable output of its industry. The ability to create not just weapons, but a continuous stream of weapons and supplies, delivered across oceans, repaired in the field, and replaced without pause. That steady stream is what made American weapons unstoppable, not because they were perfect, but because they never stopped coming. America's industrial scale was the foundation, but scale alone doesn't automatically produce unstoppable weapons, unless it's guided with a clear sense of purpose, priorities, and direction. And that's where the second part of the story begins, in the quieter world of strategy and planning, where decision makers had to ask a simple question again and again. What should we build first? What can wait? And how do we use production not just to equip our own forces, but to shape the entire war? One of the most important reasons America's weapons became so dominant is that the United States didn't treat manufacturing as a side activity that merely supported the battlefield. It treated manufacturing as the battlefield's heartbeat, something to be managed with the same seriousness as troop deployments or naval operations. And when you look closely at the American approach, what you see is not only incredible output, but a kind of calm logic behind that output. A logic that prioritized momentum, reliability, and the ability to sustain a global conflict over many years. In the early phases of World War II, before the United States was fully in the fight, American leaders were already thinking in terms of a long war, the kind of conflict that would be decided not by a single decisive moment, but by endurance and systems. And this mindset was shaped by both memory and observation. The memory was World War I, where industrial output and supply had become critical, and the observation was the rapid, frightening expansion of Axis power, especially Germany in Europe and Japan across the Pacific. In that environment, the United States understood that victory would require not just brave soldiers or strong ships, but a steady, growing current of weapons and supplies that could flow across oceans and land routes without stopping. And so, even before Pearl Harbor, American production planning was beginning to align with the needs of a world at war. One of the most powerful expressions of that planning was Lend-Lease, a program that, in a calm but far-reaching way, turned American factories into tools of geopolitical influence. Lend-Lease wasn't just generosity, and it wasn't simply an economic transaction. It was a strategic decision to keep key allies fighting, to prevent collapse, and to buy time. In practical terms, it meant that American production was organized not just to support the United States, but to support the entire Allied cause. Britain, facing bombing, submarine attacks, and the constant drain of war, needed supplies. The Soviet Union, after the German invasion in 1941, needed enormous quantities of material just to keep moving and to maintain its ability to resist. China needed aid. Smaller allies needed equipment. And even if the United States had wanted to focus only on itself, it still would have faced a simple reality. If Britain fell, the Atlantic would be far more dangerous. If the Soviet Union fell, Germany would become stronger and more secure. If supply lines collapsed, the war could shift into a very different shape. So Lend-Lease became a strategic bridge, allowing American production to influence outcomes long before American forces could fully deploy at scale. What makes this important for our theme, why American weapons became unstoppable, is that supplying allies forced America to think in terms of volume, consistency, and standardization from the very beginning. It's one thing to equip your own army and navy. It's another thing entirely to ship equipment halfway around the world, deliver it reliably, and make sure it can be used and maintained by people who didn't build it. That kind of requirement pushes an industrial system towards simplicity and repeatability. And those two qualities, simplicity and repeatability, are at the heart of what made American weapons so effective. The United States leaned into a philosophy that can be summarized in a soft, practical phrase. Build weapons that work. Build them in huge numbers and keep them working. This wasn't about chasing perfection in every detail. It was about creating equipment that could survive real-world use, that could be repaired without exotic tools, and that could be produced without constant redesign. This approach shows up again and again in American wartime engineering. Designers were often encouraged to prioritize what we might call field reliability, meaning that a weapon didn't have to be the most elegant or advanced, but it did have to function in mud, rain, dust, heat, cold, and chaos. It needed to work for tired soldiers. It needed to be forgiving. It needed to be serviceable. And the reason this philosophy mattered strategically is that reliable weapons reduce friction. They reduce the hidden costs of war, downtime, maintenance delays, training burdens, and supply confusion. A reliable weapon becomes a force multiplier, not because it is flashy, but because it is always there when it's needed. Another strategic pillar behind America's unstoppable weapons was prioritization, deciding what mattered most and then committing to it. Every wartime economy faces scarcity, even one as large as the United States. There are only so many skilled machinists, only so much aluminium and copper available at a given moment, only so much shipping capacity, only so many engines that can be produced in a month. So, leaders had to choose. And one of the reasons American production became so powerful is that it developed a disciplined, coordinated approach to those choices, using centralized planning agencies to allocate materials and resolve conflicts between competing demands. A tank needs steel, but so does a ship. An aircraft needs aluminium, but so do other aircraft. Radios need copper, but so does ammunition production. Tires need rubber, but so do countless vehicles. These competing needs could have become disorganized, with projects fighting each other for resources, but instead, American war planning pushed toward coordination. When choices were made, production lines could stabilize. And when production lines stabilize, output increases dramatically. This is one of the quieter truths of manufacturing. Consistency produces speed. A factory that keeps changing what it produces will always be slower than a factory that produces the same thing day after day, with small refinements. So the strategic decision to standardize and prioritize wasn't just administrative, it created real battlefield power months later, in the form of equipment arriving where it needed to arrive. And as America's leadership made these choices, they also shaped the war's timeline by deciding where production would concentrate. For instance, the war demanded staggering numbers of merchant ships because none of the fighting mattered if supplies could not reach Europe or the Pacific. So shipbuilding became a priority. It demanded aircraft, and not just fighters, but bombers, transport planes, trainers, patrol aircraft. So aviation production became a priority. It demanded trucks and transport vehicles, the unseen backbone of armies, so vehicle production became a priority. It demanded munitions in quantities so large they can still be hard to imagine, so ammunition plants expanded dramatically. In a calm way, the United States approached war like a problem of flow. How do we keep the flow moving from raw materials into factories, into ships, across oceans, into depots, and finally into the hands of the people using the equipment? A lot of nations focused on building powerful weapons. The United States focused on building a powerful flow, and the weapons were an extension of it. Another reason this mattered is that America, once committed, built for the long game. Some nations, especially those under immediate threat, were forced into short-term thinking. They needed results quickly. They needed emergency solutions. But the United States had the ability to make long-range plans and then follow through on them, increasing production month after month. This long-game approach encouraged investments in training and infrastructure. It encouraged building not just weapons, but the facilities to build weapons. It encouraged expanding ports, building new airfields, creating repair depots, stockpiling spare parts, and designing supply routes. And because this approach was strategic, it meant weapons were not viewed as isolated objects, but as parts of a system. A rifle is not just a rifle, it is ammunition supply, training manuals, spare parts, cleaning kits. A tank is not just a tank, it is fuel, transport, repair crews, replacement tracks, tools, and recovery vehicles. An aircraft is not just an aircraft, it is maintenance schedules, spare engines, trained mechanics, fuel depots. When American planners thought about production, they thought in systems, and this systems thinking is a major reason American weapons became so consistently effective. They weren't simply produced, they were supported into usefulness. This is also where America's approach to good enough becomes important. That phrase can sound dismissive, but it's actually deeply intelligent when used correctly. In war, a weapon that is perfect on paper but too slow to produce can be less useful than a weapon that is slightly less refined but can be produced in numbers and deployed widely. The United States embraced this balance. Instead of constantly chasing the most advanced possible design, it often selected designs that could be produced efficiently, used reliably, and improved gradually over time. This is not the same as settling. It's choosing practicality. And practicality is a powerful force in wartime because it reduces risk. Every new design introduces risk. Production delays, training confusion, supply changes, unforeseen failures. A stable design reduces those risks, allowing the entire war machine to keep moving. This is why, for example, many American designs stayed in service for long periods, and some even continued long after the war. They were built not only to win a single battle, but to endure constant use. Now, there's another strategic choice that quietly shaped the unstoppable feeling of American weapons. The decision to build vast amounts of support equipment, not just frontline weapons. It's tempting to measure military power by counting tanks or battleships, but the war was won by supply, repair, and movement as much as by firepower. The United States produced enormous numbers of trucks, bulldozers, cranes, forklifts, bridging equipment, landing craft, and transport vehicles of all kinds. These were not glamorous weapons. They didn't get the same kind of attention in newspaper headlines, but they transformed operational capability. An army that can move quickly, build roads, repair bridges, unload ships efficiently, and deliver ammunition without delay becomes far more effective than an army that cannot. So American strategic planning placed huge emphasis on mobility and logistics, and that emphasis shaped production priorities. It's why you see the United States producing, for example, a staggering number of trucks compared to some opponents. It understood that trucks were not just vehicles, they were extensions of industrial power into the battlefield itself. They allowed factories to reach the front line, in a sense, by moving the products of factories into the places where they mattered. This strategic focus also helps explain a key difference between the American and German approach. Germany produced a number of high-quality weapons, but it often struggled with standardization and logistics under heavy pressure. It produced multiple types of vehicles that required different parts and different maintenance approaches. It faced fuel shortages, it faced bombing, it faced supply chain disruptions. The United States, by contrast, focused on producing a smaller range of widely useful equipment, standardized for large-scale production and maintenance. That approach doesn't sound romantic, but it is incredibly powerful. It creates an industrial ecosystem where parts can be shared, training can be simplified, and repair can happen faster. It creates a kind of calm consistency. And consistency is what makes a system unstoppable, because it reduces points of failure. Another element to consider is the way America handled innovation. Sometimes people imagine that wartime innovation means constant reinvention, but in practice, the most effective innovation often happens in targeted areas while the main production lines remain stable. The United States did innovate, and it did develop major advances: radar systems, improved aircraft designs, new munitions technologies, better engines, and eventually the most dramatic scientific project of the war. But it didn't allow innovation to constantly destabilize production. Instead, innovation was often integrated carefully or applied where it mattered most, while keeping the bulk of output flowing. This is a subtle but crucial point. If you change too much, too often, production suffers. If you never change, you miss opportunities to improve. America found a balance, stable production with selective upgrades. And because the scale was so large, even small improvements multiplied. An improvement to engine reliability, for instance, applied across tens of thousands of aircraft, becomes a major strategic advantage. Another calm yet important factor was training and documentation. You can build weapons, but if soldiers don't understand how to use them, repair them, and operate them within doctrine, the effectiveness drops. American planning emphasized training standardization. Manuals were written, procedures were developed, support personnel were trained in huge numbers, mechanics, engineers, radio operators, logisticians, and medics were all part of the broader war machine. This means American weapons arrived not only as physical objects, but as part of an operational package. The knowledge, personnel, and support necessary to keep them working. This kind of thinking increases effectiveness without increasing drama. It turns equipment into capability. It turns steel into sustained power. And perhaps one of the most impressive strategic accomplishments was the ability to project this entire system across the ocean. The United States fought in Europe, Africa, and the Pacific, thousands of miles from its industrial base. Many nations struggled to supply armies far from home, even in peacetime, but in World War II, America supplied not only its own forces, but major Allied forces across these distances. This required convoys, escort ships, port operations, scheduling, and constant planning. It required anticipating needs months in advance. Spare parts, ammunition, consumption, fuel usage, replacement vehicles. This is where the idea of unstoppable becomes especially clear. If a unit on a distant island in the Pacific receives regular supplies and replacement parts, it can continue operating. If an airfield receives replacement engines and munitions, it can continue sending aircraft into the sky. If ships receive fuel and repairs, they can keep moving. The United States mastered this style of distant, system-based warfare, and it made its weapons feel endless because the supply behind them felt endless. And all of this ties back to an emotional truth that we can state calmly. War can be frightening, chaotic, and uncertain at the human level, but at the industrial level, it becomes a question of management, production schedules, and flow. The American approach turned that industrial level into a strategic instrument. It didn't depend on sudden bursts of brilliance. It depended on steady output. It depended on a reliable system that kept improving. It depended on prioritizing what mattered most. And it depended on recognizing that the best weapon is the one that arrives on time, works reliably, and can be repaired when it fails. If we hold all of this gently in mind, we can see why American weapons became unstoppable. Not because they were invulnerable, not because every design was superior, but because they were supported by a calm, well-directed strategy that turned production into momentum. America built a war machine that could grow, learn, and sustain itself, and it did so with a clear sense of what mattered, making sure the flow never stopped. Standardization is one of those quiet, almost invisible forces that can decide the outcome of a war without ever appearing in a dramatic photograph, because it isn't a weapon you can point at an enemy, but it is the reason weapons keep working day after day, the reason supplies arrive with fewer mistakes, the reason repairs happen quickly instead of slowly, and the reason armies can expand without collapsing under their own complexity. When people imagine the American advantage in World War II, they often think of huge factories and endless convoys. And that's all true, but behind that scale was a disciplined idea that shaped everything. Standardize as much as possible, simplify wherever you can, and make sure that one part can replace another without needing a custom solution. This idea might sound ordinary today because we live in a world where mass production is normal, where you can replace a broken component with a new one that fits perfectly. But in the early 20th century, this was still a major advantage, and in wartime, it becomes something close to a superpower. Standardization meant that the United States could build equipment not as one-off masterpieces, but as predictable, repeatable products. It meant that training could be consistent. It meant that supply officers could plan with more confidence. It meant that repair crews could stock fewer types of spare parts and still fix more machines. And over time, this quiet efficiency created a form of unstoppable momentum because every improvement in standardization reduced friction across the entire war effort. To understand why standardization matters so much, imagine war as a constant stream of small problems that need solutions. A truck breaks down, a rifle jams, a radio fails, a tank throws a track, a ship needs a replacement part for a pump, an aircraft needs an engine component. If each of those problems requires a unique solution, then the system slows down. You need specialized parts. You need specialized training. You need specialized tools. And when the war is global, those specialized needs become very difficult to meet everywhere at once. But if many of those problems can be solved with standardized parts, standardized procedures, and standardized equipment, then the system stays fluid. A part can be shipped from one depot to another and still be useful. A mechanic trained in one location can work in another with the same methods. A factory can produce one component that serves thousands of machines. Standardization is what turns a collection of weapons into a cohesive machine, and it is what allows a nation to scale its power without losing control. The American industrial culture before the war had already absorbed standardization in many ways, especially in sectors like automobiles, appliances, and machinery. The United States had embraced assembly lines, interchangeable parts, and large-scale consumer manufacturing. When war came, this cultural habit became invaluable. It meant that America didn't just have factories. It had factories that understood how to produce large quantities of consistent products. This is important because in war, consistency is not boring. Consistency is survival. If a weapon is produced with inconsistent tolerances, it breaks. If parts don't fit each other reliably, repairs slow down. If ammunition varies too much, performance changes. Standardization means predictability, and predictability means the people using equipment can trust it. That trust matters. It reduces stress. It makes training more effective. It means soldiers can focus on their tasks rather than worrying whether their equipment will fail. And when you multiply that trust across millions of soldiers and sailors and pilots, it becomes a strategic advantage. One of the best ways to see standardization at work is to think about interchangeable parts. In earlier eras, craftsmen often produced weapons and machines with parts that were fitted individually. A musket might be repaired with a hand-fitted component. A vehicle might require a part that was filed and adjusted to match a specific machine. That kind of craftsmanship can create high-quality products, but it does not scale well. In wartime, scalability matters. Interchangeability means that a bolt produced in one factory can fit into a machine produced in another. It means that a replacement part shipped across the ocean will install without hours of fitting. It means that the field repair system becomes practical. And field repair is crucial because in war you don't have the luxury of returning everything to a central workshop. Equipment breaks near the front. It breaks in mud and snow and rain. It breaks in deserts and jungles. If you can't repair it, you lose it. And if you lose too much equipment too quickly, your power fades. Standardization slows that fading. It keeps machines alive longer. It lets you reuse what you've already built. It increases what we might call uptime, meaning the percentage of time equipment is operational. In a global war, uptime can matter as much as raw numbers. Another key advantage is that standardization reduces the variety of items that must be produced and supplied. The more unique models of equipment a country uses, the more complex its supply system becomes. Different vehicles require different engines. Different engines require different parts. Different parts require different manufacturing processes. Different manufacturing processes require different machine tools and training. This web of complexity creates vulnerabilities. If one specialized part becomes scarce, an entire category of equipment may become unusable. If one factory is destroyed or disrupted, it can ripple through the system. Standardization reduces those vulnerabilities by narrowing the variety of critical parts. When you standardize, you also standardize your risks. You make the system more resilient. This was especially important for the United States because it was fighting on multiple fronts. It had to supply forces in Europe, North Africa, the Middle East, the Pacific, and China. It had to equip the Army, the Navy, the Marine Corps, the Air Forces, and allied nations. Complexity could have crippled such an effort. Standardization was a way to keep complexity manageable. It was a way to prevent the war machine from collapsing under its own weight. Now, standardization didn't happen automatically. It required decisions, and sometimes those decisions were not easy. Different companies might prefer different designs. Different branches of the military might request unique features. Engineers might want to improve a design frequently, but each change introduces variations that complicate production and supply. American wartime management had to balance innovation and improvement with the need for stable production. One solution was to standardize core components while allowing controlled variations. Another was to enforce standards through procurement policies and centralized planning. The military could require that certain parts meet specific dimensions and tolerances. It could require compatibility across different production sites. This is where the relationship between government and industry becomes important again. In wartime, the government could push industry towards standardization in a way that peacetime competition might not. And while this could frustrate companies in the short term, it created a huge advantage in the long term. Standardization also shaped the way weapons were designed. In a wartime environment, a good design is not only one that performs well, it's one that can be built. It's one that can be built quickly. It's one that can be built consistently. And it's one that can be maintained with minimal specialized effort. This affects the shape of weapons. It affects how many different fasteners are used. It affects how assemblies are constructed. It affects whether components are modular. It affects whether parts can be swapped. In many American designs, you can see a quiet preference for simplicity and ruggedness. This isn't the kind of detail that makes a weapon famous in the popular imagination, but it's exactly the kind of detail that makes a weapon last. And it's exactly the kind of detail that makes a weapon unstoppable when produced at scale. Standardization also improved training. In war, training is one of the most important limiting factors. You can build equipment, but you need people who know how to use it, and not just combat troops, but mechanics, radio operators, armorers, drivers, logisticians, and countless specialists. Standardized equipment means standardized training. It means that instructional materials can be produced in bulk. It means that a recruit trained on one rifle will not be confused when handed another rifle. It means that a mechanic trained on one truck can likely work on another truck with similar systems. This reduces the learning curve and speeds up deployment. In a war where time matters, reducing training time even slightly can have major effects. It allows a nation to expand its forces faster. It reduces errors. It improves safety. It increases efficiency. And it gives commanders more confidence that units can be replaced and expanded without losing quality. Another important dimension of standardization is ammunition and fuel. A weapon is only as useful as its ammunition supply. A vehicle is only as useful as its fuel supply. Standardized ammunition types simplify production and distribution. Standardized fuel types simplify supply planning. If you have too many calibers of ammunition in use, you create headaches for supply officers and risks for frontline units. A unit might run out of the specific ammunition it needs, even when other ammunition is abundant. Similarly, if vehicles require different fuel types, supply chains become more complicated and mistakes become more damaging. The United States emphasized standardization in these areas, reducing the number of incompatible categories that had to be supported. This, again, reduced friction. It is one reason American forces could sustain long operations far from home. They could keep machines running because supply systems were simplified. It also meant that American factories could focus production on fewer categories, increasing output and consistency. One of the best examples of American standardization is in vehicles and parts. The United States produced enormous numbers of trucks, jeeps, and other transport vehicles, and these vehicles were often designed with maintenance in mind. Parts were standardized, repair kits were created, manuals were distributed widely. The result was that vehicles could be repaired in the field and returned to service quickly. In war, this matters more than people often realize. If a truck fleet becomes unreliable, supply lines slow down. If supply lines slow down, artillery runs low on shells, troops run low on food, and operations begin to stall. So the humble standardized truck part becomes part of combat power. It becomes part of what makes weapons unstoppable, because it keeps the system moving. The same logic applies to ships. Ships are complex machines, full of pumps, valves, turbines, generators, and countless components. If ships are built with standardized parts, then repairs become faster. If parts can be swapped between ship classes or sourced from common inventories, then maintenance becomes more efficient. American shipbuilding expanded rapidly, and while different ship classes existed, there was an emphasis on repeatable construction methods. Liberty ships, for example, were built in huge numbers with simplified designs. Their purpose wasn't elegance, it was dependable delivery of cargo. And because they were standardized, shipyards could build them faster, workers could learn the process quickly, and repairs could be organized more efficiently. When German submarines targeted shipping, the American response was not only to fight submarines, but to replace ships faster than they could be sunk. That replacement depended on standardization and mass production. And when you can replace a ship faster than it can be destroyed, that begins to look unstoppable. There's also a deeper psychological element to this. Standardization creates a sense of certainty within an organization. When everyone uses the same equipment, communication improves, expectations align, procedures become routine. Routine might sound dull, but in war, routine reduces stress and improves performance. A soldier who knows how to clean and maintain his rifle has one less worry. A driver who knows how his truck behaves can focus on the road. A mechanic who recognizes an engine layout can work efficiently. These small reductions in uncertainty improve operational effectiveness, and in the long term, they create a culture of competence. Competence is not dramatic, but it wins wars. The American war machine was built on competence at scale. Millions of people doing tasks correctly and repeatedly. Standardization supports that. It creates repeatable competence. Another advantage is that standardization makes improvements easier to implement. If you have a standardized platform, you can introduce an upgrade across thousands of units. If you have a highly diverse set of designs, upgrades become complicated, and improvements might only apply to small subsets. The United States, with large standardized production runs, could incorporate feedback and refine designs in a controlled manner. Combat reports could identify issues, engineers could adjust, factories could implement changes. Because the system was standardized, these changes could spread widely. This created an iterative advantage. Weapons and equipment gradually improved over time, while still maintaining compatibility and production stability. It's a calm kind of learning, a learning machine embedded in the production system itself. And that learning machine contributed to the unstoppable feeling because American equipment didn't just appear in large numbers. It evolved into greater reliability and effectiveness. Of course, standardization had limits and challenges. Sometimes a standardized approach can lead to compromises. A design chosen for ease of production might not be ideal in every tactical context. But the American experience shows that in a global industrial war, the strategic value of standardization often outweighs the downsides. Because in war, battles are not fought in isolation. They are fought as part of campaigns, and campaigns depend on sustained supply. A slightly less optimal weapon that is always present can outperform a superior weapon that is absent. Standardization makes presence possible. It ensures that equipment is not only built, but built consistently, built in quantity, and supported with a manageable supply chain. It keeps the war machine from fragmenting into confusion, and it allows a nation to focus its resources. When the United States standardized, it concentrated power. It reduced waste. It reduced delays. It reduced the number of unique problems that needed solving. It increased the speed at which solutions could be applied. This is why standardization truly deserves the title of a quiet superpower. It is not glamorous, but it shapes the outcomes of wars in a deep, structural way. And when you step back and observe the Second World War as a massive industrial contest, it becomes clear that America's approach, standardizing production, enforcing compatibility, simplifying logistics, helped transform its weapons into something that felt endless and unstoppable. Not because every weapon was extraordinary on its own, but because every weapon belonged to a larger system that could keep moving, keep repairing, keep supplying, and keep producing without drowning in complexity. And in a war defined by the demands of global scale, that quiet ability to simplify and repeat became one of the most decisive forces on Earth. When people talk about why American weapons became so effective in World War II, there's a temptation to jump straight to the big machines and dramatic symbols, tanks, aircraft, ships, because those are visually impressive and easy to remember. But the truth is that the everyday experience of the war for millions of American infantrymen was defined by something much smaller and far more personal. The rifle they carried, the ammunition they depended on, and the quiet confidence that their weapon would work when it needed to. And in that category, one of the most important reasons American firepower felt so steady and so consistent was the M1 Garand, a rifle that wasn't just a piece of metal and wood, but a carefully chosen solution to a deep problem in modern warfare. How to give ordinary soldiers a weapon that could keep pace with the speed and pressure of 20th century combat without demanding an unrealistic level of maintenance, training, or mechanical understanding. The M1 Garand is often remembered with a kind of reverence, and for good reason. But what matters for our calm, factual exploration tonight is not the mythology around it, but the practical reasons it made a difference. The Garand wasn't unstoppable because it was perfect, and it wasn't unstoppable because it made soldiers fearless. It became part of an unstoppable system because it matched America's industrial philosophy. Reliable, repeatable, and designed to work in the hands of large numbers of people. It took the idea of semi-automatic fire and turned it into a standardized infantry advantage that could be produced at scale, supplied at scale, and maintained at scale. In other words, it wasn't just a good rifle, it was a rifle that fit into an industrial war machine. Before the Garand, many armies relied heavily on bolt-action rifles as their standard infantry weapons. Bolt-action rifles could be accurate and powerful, and many were very well made. But bolt-actions have a mechanical limitation. After each shot, the shooter must manually cycle the bolt to load the next round. This takes time and disrupts the rhythm of firing. In a calm setting, on a range, this isn't necessarily a problem. But in combat, where seconds matter, where targets appear briefly, and where suppression and tempo shape movement, the ability to fire multiple rounds quickly without manually cycling a bolt can become a meaningful advantage. The M1 Garand provided that advantage by being semi-automatic, meaning it used the energy of the firing cycle to automatically eject the spent cartridge and load the next round. The shooter still had to pull the trigger for each shot, but the rifle handled the cycling. This increased practical rate of fire, and more importantly, it reduced the physical and mental burden on the soldier. In war, anything that reduces burden increases effectiveness. Now, it's important to be precise and calm about what this advantage meant. The Garand didn't turn every soldier into a perfect marksman. It didn't guarantee victory in every firefight, but it changed the baseline. It increased the average amount of firepower an infantry squad could deliver. It made it easier to maintain suppressive fire while maneuvering. It made it easier for soldiers to respond quickly when surprised. And when you add these small advantages across thousands of encounters, across hundreds of campaigns, it becomes a significant strategic factor. One reason this mattered so much is that infantry combat in World War II often involved short-range engagements, sudden contact, and movement through varied terrain forests, villages, hills, hedgerows, jungles. In those environments, the ability to fire quickly and reliably could help units maintain control of a situation. And that control, that calm sense that your weapon will work and you can respond, shapes behavior. It shapes decisions. It shapes the way squads move and coordinate. In that sense, the Garand became more than a gun. It became part of the doctrine of American infantry, a piece of equipment that allowed tactics to be executed with more speed and confidence. But the Garand's real story, and the reason it fits so well into our larger theme about unstoppable weapons, is not only its battlefield performance, it is also the fact that the United States chose to equip its standard infantry with this kind of rifle at scale. That decision is striking because it reflects a willingness to invest industrial resources into a weapon that was more complex than a bolt-action rifle. Semi-automatic rifles generally require more parts, tighter tolerances, and more careful manufacturing. They can be more expensive. Some nations avoided issuing semi-automatic rifles widely for these reasons, preferring to keep bolt actions as standard and reserve semi-automatics for specialized roles. The United States did the opposite. It made the Garand the standard, and then it produced it in huge numbers. This reflects confidence in industrial capability. It also reflects the American preference for giving soldiers a dependable tool that could increase their effectiveness without demanding heroic effort. In a way, it's very American. Take a complex solution, simplify its use, and mass produce it until it becomes normal. The Garand itself was developed through a long process of testing and refinement. It wasn't the first attempt at a semi-automatic service rifle, and it wasn't adopted casually. It emerged from a culture of careful evaluation, trials, and iterative improvement. This matters because the rifle that enters combat is not just a design, It is the result of decisions made years earlier about reliability, standards, safety, maintainability, and practicality. The Garand was designed to withstand the conditions of real military use, meaning it had to function even when dirty, even when handled roughly, even when used by soldiers with limited mechanical knowledge. It needed to be robust, it needed to tolerate imperfect conditions, and it needed to do so while firing a full power cartridge capable of effective range and stopping power. In this sense, it combined modern firepower with traditional infantry expectations, and that combination is part of why it became such a respected weapon. One of the most distinctive features of the M1 Garand is its on-block clip system, which held 8 rounds and was inserted into the rifle as a unit. This system is often remembered for the characteristic sound the rifle makes when the clip ejects after the last round, a sound sometimes described as a ping. It's become part of popular memory, but calmly speaking, what matters is the practical effect of the system. The on-block clip allowed rapid loading, it kept ammunition organized, and it simplified handling. It wasn't perfect, no system is, and later rifle designs would move toward detachable box magazines. But in the context of World War II, the Garand's feeding system was functional, reliable, and suited to mass supply. Clips were easy to carry, ammunition could be issued in standardized units, soldiers could be trained quickly to load and fire efficiently, and because the Garand was standardized across American infantry, supply systems could be built around it with confidence. Ammunition, distribution, spare parts, stocking, repair training, all of it could be planned around a single dominant infantry rifle. That is exactly how a weapon becomes part of an unstoppable system. It becomes predictable. It becomes supported. It becomes integrated into every level of planning. Another important aspect of the Garand is the way it affected squad-level dynamics. In many armies, bolt-action rifles were the standard and the primary source of rifle firepower, while automatic weapons like light machine guns provided suppressive fire. In American squads, the Garand increased the firepower of each individual rifleman. This meant squads could generate more consistent fire without relying solely on automatic weapons. It didn't eliminate the need for machine guns, but it increased overall fire density. This had subtle tactical consequences. It could make ambushes more effective. It could make defenses more resilient. It could reduce the time needed to respond to contact, and it could allow American units to maintain pressure during assaults. Again, this is not about dramatic heroism, it is about tempo. Tempo is often the hidden currency of combat. The side that controls tempo, who fires when, who moves when, who forces the other side to react, often has an advantage. The Garand contributed to American tempo by allowing riflemen to keep firing without pause. Now, there's also a human factor here that matters for our goal of a soothing, emotionally neutral narrative. A soldier's relationship with his weapon is intimate. It's a tool of survival. When a weapon is reliable, the soldier feels less uncertainty. When a weapon is easy to use, the soldier can focus more on the environment and less on mechanical tasks. When a weapon can fire quickly, the soldier can respond without the stress of constant manual cycling. These are small psychological advantages that matter over long periods. They reduce fatigue, they reduce frustration, they reduce the feeling of helplessness in unpredictable situations. And while we don't need to dramatize battlefield fear, we can calmly acknowledge that reliable equipment contributes to steadiness. It contributes to the ability to function. In a war as large and exhausting as World War II, any tool that helps individuals stay steady becomes valuable. The Garand did this. But the Garand also demonstrates something bigger about American wartime culture. A belief that equipment should be designed around the user. and that the user should be supported by a system. The rifle was not issued in isolation. Soldiers were trained. Ammunition was supplied consistently. Spare parts were available. Armourers existed. Repair depots existed. Manuals existed. The Garand's effectiveness wasn't just mechanical, it was organisational. A semi-automatic rifle can be excellent, but if it's issued without enough maintenance support, it becomes a liability. The United States avoided that problem by building support into its war machine. That support made the rifle practical, it also made it durable. Many Garands continued to serve long after World War II, which says something about the design's longevity. Longevity is a kind of quiet validation. If something remains useful across decades, it probably solved its problem well. The M1 Garand wasn't alone in American infantry firepower, of course. The US also fielded other weapons, like the M1 carbine, designed to be lighter and easier to carry for support troops, officers, and others who needed a weapon but not necessarily a full-power rifle. The US used submachine guns like the Thompson and the M3 grease gun, and it had excellent machine guns and mortars. But the Garand stood at the centre of the infantry experience, and it symbolised the American approach. Give the ordinary soldier a dependable advantage, then reinforce that advantage with mass production and supply. The rifle was produced in huge numbers, and that alone is significant. Mass production of a semi-automatic rifle requires disciplined manufacturing and consistent quality control. It requires a supply chain of steel, springs, and precision parts. It requires skilled and semi-skilled labour. It requires tooling, and the fact that the United States could do this while also producing ships, aircraft, tanks, trucks, and ammunition speaks again to the industrial scale we discussed earlier. The Garand was not only a weapon, it was proof that American industry could deliver complexity without losing reliability. And in war, that's a powerful thing. If you can reliably produce complex machinery in massive numbers, you can shape the battlefield indirectly by shaping what your soldiers carry and how they fight. Another reason the Garand helped American weapons feel unstoppable is that it contributed to the consistency of American infantry forces. When an army expands rapidly, as the US Army did during the war, you risk uneven quality. New units might not be as trained, equipment might vary. But the Garand helped standardize the infantry experience. It meant that whether a soldier was in Europe or the Pacific, he likely carried the same primary rifle. Training systems could be consistent. Ammunition supply could be consistent. Repair procedures could be consistent. That consistency reduces chaos. And reducing chaos is a form of strength. It means units can be integrated more easily. It means replacements can adapt faster. It means logistics can anticipate needs. And it means that as casualties occurred and units rotated, the system didn't reinvent itself each time. It stayed steady. That steadiness is one of the key characteristics of unstoppable systems. They don't collapse under stress. They absorb stress and continue functioning. Now, if we compare this to some opponents, the contrast becomes clear. Many Axis forces relied heavily on bolt-action rifles as standard. Some had semi-automatic rifles, but they were not always widespread. Others had excellent machine guns and effective small arms overall, but their infantry standardization and supply consistency could suffer under pressure. German forces, for example, faced increasing strain as the war progressed, fuel shortages, bombing of industry, and an ever-growing need for replacement equipment. Japan faced severe material shortages and shipping losses. As these pressures mounted, maintaining consistent equipment and supply became harder. The United States, protected by its geography, and supported by its industrial machine, could maintain consistency longer. That meant weapons like the Garand continued to arrive, continued to be supported, continued to be used effectively. That consistency created an asymmetry. One side's soldiers were being steadily equipped with reliable weapons, while the other side increasingly struggled to replace losses. Over time, asymmetry becomes outcome. Not because one battle decides it, but because the trend becomes hard to reverse. The Garand thus fits into our theme perfectly. It was not the most advanced weapon in the war, and it was not flawless, but it was exactly what American strategy needed: a dependable, mass-producible rifle that improved infantry tempo and fit smoothly into a larger standardized system. It gave American squads a little extra speed, a little extra steadiness, and a little extra power. And that little extra, multiplied across millions of rifles and countless engagements, contributed to a larger feeling that American forces could keep coming, keep firing, and keep moving forward with calm inevitability. In a global conflict where so many variables were uncertain, the certainty of a reliable rifle in the hands of a soldier mattered more than it might seem at first. And in the grand pattern of World War II, the M1 Garand becomes one more example of a larger truth. American weapons became unstoppable, not because they were always superior in isolation, but because they were built to work within a system that emphasized reliability, supply, and scale. And that system kept pushing forward, quietly, steadily, and without running out of breath. One of the most quietly remarkable things about American weapons in World War II is that some of the most important pieces of equipment weren't the ones people talked about with dramatic excitement, but the ones that simply worked, over and over, in almost every environment, on almost every front, and in the hands of an enormous variety of people with different levels of training and experience. And among those weapons, there's a name that comes up again and again, not because it was flashy, but because it was dependable: John Browning. Browning wasn't a wartime celebrity in the way a general might be, and his legacy isn't always presented in a soothing documentary tone. But if we're calmly asking why America's World War II weapons became so unstoppable, his influence is almost impossible to ignore, because the Browning-designed systems formed the backbone of American automatic firepower. And the story here isn't just that Browning weapons were powerful, it's that they were rugged, adaptable, standardized, and capable of being produced and maintained at the scale required by a global war. In other words, Browning weapons didn't just win fights. They supported the entire American style of fighting, which relied heavily on sustained fire, combined arms coordination, and logistics-driven momentum. To understand why this mattered, it helps to remember what automatic weapons represent at a practical level. A rifle is personal. It belongs to one soldier. A machine gun, in contrast, is often a team weapon. It can shape an entire engagement. It can suppress movement. It can anchor a defensive position. It can provide covering fire for an advance. In a modern battlefield, machine guns are not simply weapons. They are tools that control space. They create zones of danger that influence decisions. They force the enemy to take cover, to move more cautiously, to burn time. And time, in warfare, is as valuable as territory. The side that can control time often controls the tempo of battle. The United States, with its industrial strength and its focus on sustained operations, understood the value of dependable automatic firepower, and it leaned on Browning systems to provide it. Among these systems, the most famous is probably the M2 Browning 50 caliber machine gun, often called simply the Mardoos. It's hard to overstate how significant this weapon became, not just in World War II but in later decades as well. But for our purposes, what matters is why it mattered during the war itself. The M2 was powerful, yes, but its deeper value was versatility and reliability. It could be mounted on vehicles, tanks, aircraft, ships, and defensive positions. It could be used against aircraft at low altitude. It could be used against lightly armoured vehicles. It could be used to suppress enemy positions. It could be used in ways that blurred the line between small arms and artillery. And because it was dependable, units came to trust it. Trust is a recurring theme in this story. In war, trust in equipment reduces uncertainty, and reduced uncertainty creates steadier performance. The M2 Browning didn't require constant attention to function. It didn't demand delicate treatment. It could be integrated into many platforms. And that integration matters because American strategy relied heavily on mobility and mechanization. If you can mount a powerful, dependable weapon on trucks, half-tracks, tanks, and ships, you spread firepower everywhere your logistics network reaches. And because American logistics could reach far, that meant Browning firepower could reach far too. But the M2 is only one part of the story. Another major Browning system was the M1919, a 30 caliber medium machine gun. The M1919 existed in multiple variants and was widely used across the war. It appeared on vehicles, in aircraft, and as a ground weapon. Its importance lies not only in its performance, but in its role as a standardized tool that could be produced in huge quantities and used across different contexts. Standardization, again, is key. When you can use similar weapons across multiple platforms, you simplify training and maintenance. You simplify ammunition supply. You simplify spare parts. You reduce the variety of unique problems that need solving. And this is how a weapon becomes part of an unstoppable system. It creates consistency across the force. The M1919 could provide sustained fire for infantry units, but it also served as a vehicle-mounted weapon, providing protection and offensive capability for convoys and mechanized units. That matters because the United States relied heavily on movement, moving supplies, moving troops, moving equipment. Movement creates vulnerability. A convoy on a road is vulnerable to ambush. A supply line is vulnerable to disruption. So giving those convoys and vehicles dependable machine guns helped protect the flow of logistics. This is one of the most overlooked ways machine guns contribute to strategic power. They don't just support frontline assaults. They protect the supply system that keeps the war machine alive. In this way, Browning weapons helped turn American logistics into a protected artery, one that could continue pumping resources forward even in contested environments. And because the flow continued, American weapons continued arriving. And because weapons continued arriving, the system felt unstoppable. Now, there's a quiet engineering beauty to Browning weapons that is worth noting in a calm way. Browning's designs were often praised for their mechanical simplicity and reliability. That doesn't mean they were simplistic, it means they were efficient. Efficient mechanisms tend to survive wartime abuse because fewer unnecessary complications mean fewer failure points. And in war, failure points multiply. Dirt gets into mechanisms. Lubrication becomes inconsistent. Parts wear. People handle weapons roughly. Weather interferes. A weapon that functions reliably in these conditions becomes highly valued. This is why Browning systems developed reputations not as temperamental weapons, but as trustworthy ones. And trust becomes doctrine. When commanders trust that a weapon will function, they plan around it. They integrate it into tactics. They rely on it in defensive positions. They mount it on vehicles. They put it on ships. They incorporate it into air defense. They make it part of the assumed environment of the battlefield. That is a powerful form of influence. The weapon becomes a constant, a stable piece of the war's rhythm. The United States also benefited from Browning weapons because they aligned well with American manufacturing strengths. Browning designs could be produced with industrial processes, and they could be produced with consistent quality. This matters because a weapon is only as good as the quality of its production. If manufacturing tolerances vary too widely, reliability suffers. The American industrial machine, with its emphasis on repeatable production and quality control, could produce Browning weapons at scale while maintaining the reliability that made them valuable. And because they were produced at scale, they could be issued widely. Wide issue matters. It means more units have access to dependable firepower. It means more convoys can be defended. It means more tanks can be equipped. It means more aircraft can carry guns. It means ships have defensive weapons. It means the war machine becomes more evenly armed, reducing weak points. In a global war, weak points are dangerous because they invite exploitation. A system with fewer weak points is harder to break, and that, again, contributes to the unstoppable feeling. The Browning family of weapons also extended into other areas. The M1918 Browning automatic rifle, the BAR, is one example. It occupied a sort of middle ground between rifle and machine gun. It was used as a squad automatic weapon and provided portable automatic fire. It wasn't a light machine gun in the modern sense, but it delivered something crucial, a way to bring sustained fire into small unit tactics. This helped squads maneuver. It helped provide suppressive fire. It helped during assaults and defences. And like other Browning designs, it became valued for reliability. Now, if we step back and look at American combined arms warfare, the way infantry, armour, artillery, and air support work together, we can see why dependable automatic weapons matter so much. Combined arms is not simply having multiple types of weapons. It is coordinating them so that each supports the other. Infantry holds ground and clears terrain. Tanks provide armoured firepower and mobility. Artillery provides indirect fire and suppression. Aircraft provide reconnaissance and strike capability. But machine guns are woven through all of it. They are on vehicles. They are in infantry units. They are on aircraft. They are on ships. They are defensive. They are offensive. They create the baseline level of continuous fire that makes movement possible. Without machine guns, maneuver becomes more dangerous. With machine guns, maneuver becomes more controllable. So the Browning systems were not isolated tools. They were connective tissue in the American war effort, linking different branches and platforms through a common, reliable source of firepower. This is especially true in the Pacific, where amphibious operations demanded weapons that could endure salt air, humidity, and rough handling. Marines and soldiers landing on beaches needed dependable firepower immediately. Vehicles needed weapons mounted. Ships needed defensive guns. Aircraft needed guns. Browning systems helped fill these needs. In Europe, mechanized warfare and constant movement meant vehicles needed weapons for defense and for rapid engagements. Tanks needed coaxial guns. Half-tracks needed machine guns. Trucks needed protection. Browning weapons were everywhere. Their presence created a kind of consistent American signature on the battlefield. Wherever American logistics reached, these weapons appeared, standardized and dependable. And this consistency mattered not only tactically, but psychologically. An opponent facing American forces encountered an environment dense with reliable automatic weapons. Defensive positions could expect machine gun fire. Convoys could defend themselves. Aircraft might carry heavy machine guns. Tanks might have mounted weapons. Ships had anti-aircraft mounts. This created a sense that American forces were always equipped, always ready, always covered. It reduced opportunities for easy success. It forced the enemy to plan more carefully. It added friction to enemy operations. And friction is one of the quiet killers of wartime plans. The more friction you create for an opponent, the more mistakes they make, the slower they move, and the more they hesitate. Browning weapons, through their widespread and reliable presence, added that friction. Another important reason these weapons were part of the unstoppable American system is the way they were supported. A machine gun is only effective if it has ammunition. The United States could supply ammunition in huge quantities, and its industrial base could keep producing it. This is a theme that repeats constantly. A weapon's design matters, but its supply matters just as much. Browning weapons used standardized ammunition types, and American industry could produce those rounds in massive numbers. The supply system could deliver belts and boxes, and spare barrels and replacement parts. The maintenance system could repair and refurbish weapons. So Browning weapons didn't simply exist in a unit, they existed within a maintenance ecosystem. That ecosystem ensured the weapons stayed in service and kept functioning. In contrast, a nation with limited supply might have excellent weapons, but struggle to keep them fed and repaired. In that case, a machine gun becomes less valuable over time. The American advantage was that Browning weapons could stay active and supported. They were not temporary advantages, they were sustained advantages, and sustained advantages win campaigns. It's also worth noting that American war production didn't just flood the battlefield with weapons, it also flooded the battlefield with spare parts. This is an underappreciated element of why American weapons stayed effective. Spare parts are not glamorous, but they keep weapons running. A broken extractor, spring, or feed component can disable a weapon. If you can replace it quickly, the weapon stays in service. If you cannot, the weapon becomes dead weight. Browning weapons, produced in huge numbers, had a large pool of parts. Repair depots could stock those parts. Armourers could perform repairs. This created resilience. Even when weapons wore out, they could be rebuilt. Even when a gun was damaged, it could be salvaged. And because the United States had the industrial capacity to do this repeatedly, the weapons didn't fade away. They remained present. The system remained dense with firepower. And density of firepower is a form of control. In the calm analysis of war, control is what turns strength into outcome. Another subtle advantage of Browning systems was that they became familiar. Familiarity reduces mistakes. A soldier trained on a Browning machine gun could recognize its behavior, troubleshoot jams, and maintain it. Training programs could be standardized. Manuals could be widely distributed. Because these weapons were common, knowledge spread quickly. Experience accumulated. Small improvements in how to operate and maintain the guns became part of unit culture. That accumulation of experience is a quiet form of power. It means a weapon becomes more effective, not necessarily because it changes, but because the people using it become better at using it. This is another way systems become unstoppable. They learn, they improve, they become more efficient through experience. And because Browning weapons were so widespread, the experience base was huge. Finally, we can gently reflect on something important. The unstoppable nature of American weapons was never about a single moment of dominance. It was about the steady presence of effective tools, again and again, across years of war. Browning systems helped create that steady presence. They were not experimental novelties. They were dependable workhorses. They were weapons that could be mounted anywhere, used by many, and maintained by a system designed for endurance. They fit perfectly into American wartime logic: produce, supply, sustain. And when you place reliable automatic weapons into a war machine that can deliver endless ammunition, endless spare parts, and endless replacements, you create a kind of calm inevitability. Not inevitability in the moral sense, but inevitability in the mechanical sense. The enemy might win battles. The enemy might achieve successes, but the American system keeps generating capability. And as long as the system keeps generating capability reliably, steadily, and without collapsing, its weapons will feel unstoppable. Browning weapons were not the only reason this happened, but they were a major reason, because they ensured that wherever American forces moved, they carried with them a baseline of reliable firepower that could anchor, defend, suppress, and protect the flow of the larger war machine, quietly supporting the momentum that ultimately shaped the outcome of the war. If you want to understand why American weapons in World War II became unstoppable in a practical, almost mechanical sense, there's a certain point where you have to stop looking only at guns and cannons and start looking at something even more influential, something that often decides wars without getting the same recognition: movement. The ability to move people, fuel, ammunition, food, medical supplies, spare parts, radios, artillery shells, bridging equipment, and replacement vehicles across enormous distances, in every kind of terrain, in every kind of weather, day after day, without the whole system collapsing. And this is where America's real signature begins to appear clearly, because the United States didn't just build weapons that fought battles, it built the mobility that made battles possible. It built the trucks, jeeps, and transport networks that turned its industrial power into battlefield power. In a calm way, you can think of this as the difference between owning a warehouse full of tools and actually having those tools in your hands exactly when you need them. Mobility is the delivery mechanism of power, and in World War II, American mobility was so extensive that it changed the nature of warfare for the forces that depended on it. It's not an exaggeration to say that American trucks and vehicles were among the most important weapons of the entire conflict, because they multiplied every other weapon's usefulness. A rifle is more useful if ammunition arrives. A tank is more useful if fuel arrives. Artillery is more useful if shells arrive. Aircraft are more useful if spare parts arrive. And troops are more useful if food arrives. Mobility is what makes all of those things happen. Without mobility, even the best weapon becomes stranded in time and space. With mobility, even a fairly ordinary weapon becomes dangerous because it can be brought to the right place at the right moment. This is one of the deepest reasons American weapons became unstoppable. The U.S. mastered the ability to transport capability, and the most visible symbol of that mastery in the everyday life of the war was the Jeep. The Jeep is one of those objects that has become legendary, almost like an icon of the 20th century. People often remember it as charming, rugged, simple, and practical. Those qualities are real, but the true significance of the Jeep is that it represents the American philosophy of functional design and mass production perfectly. The Jeep, officially known as the Willys MB in its most famous form, was designed to meet a set of military needs that were both demanding and surprisingly specific. It needed to be light enough to transport easily, strong enough to survive rough terrain, simple enough to maintain in the field, and versatile enough to perform countless tasks that no one could fully predict ahead of time. and it needed to be produced quickly in huge numbers. That's the part that turns the Jeep from a clever vehicle into a strategic tool. A nation can design a useful vehicle, but if it can't produce it at scale, the impact is limited. The United States produced Jeeps in enormous numbers, and because of that, the Jeep became everywhere. It became a kind of universal mobility platform. It carried officers. It carried messengers. It carried radios. It carried medical supplies. It towed small guns. It transported small squads. It served as a reconnaissance vehicle. It became an ambulance. It became a command vehicle. It became a logistical helper for tasks so routine that they never appear in heroic war stories, moving parts from one depot to another, delivering messages, pulling equipment out of mud, helping reposition supplies. The Jeep's brilliance wasn't only in what it could do, but in how often it could do it. It created a constant layer of mobility that filled the gaps between larger vehicles and major supply operations. And that constant layer reduced friction. It allowed small problems to be solved quickly. It let units move information and supplies without delay. It helped command systems function smoothly. And when command systems function smoothly, operations become steadier. The Jeep is a classic example of how American equipment wasn't always about sheer destructive power. It was about enabling. It enabled the war machine to operate with fewer obstacles. Now, beyond the Jeep, the real backbone of American mobility was the truck. Trucks were the arteries of the Allied war effort, and if the Jeep was the quick-moving, versatile messenger, the truck was the heavy lifter that made the whole system work. The United States produced trucks in numbers that are still hard to fully appreciate. Among the most important was the 2.5-ton truck, often called the Deuce and a Half. These trucks could move supplies in bulk: ammunition, fuel, food, building materials, medical equipment. They could travel over rough roads. They could be repaired relatively easily, and they could be operated by drivers with standardized training. The Deuce and a Half became so essential that it's almost fair to say it was one of the most decisive American weapons. Not because it shot at anyone, but because it ensured that the people who did the shooting had what they needed. The ability to keep supply moving is not glamorous, but it is decisive. And the United States didn't just produce a few trucks. It produced them in such large numbers that it could support massive movements of armies across continents. In North Africa, in Italy, in Western Europe, in the Pacific, trucks helped turn beachheads into campaigns. They turned captured ports into flowing pipelines. They turned airfields into functioning bases. They turned victories into momentum. And the presence of these trucks meant that American and Allied forces could move faster, recover more quickly, and sustain longer operations. Speed matters in war. It allows exploitation of opportunities. It allows the concentration of force. It allows redeployment to meet threats. And a supply system that moves fast increases operational tempo. Tempo, again, is that hidden currency. The side that maintains tempo forces the other side to react. Trucks were tempo machines. They ensured that momentum didn't die due to lack of supplies. They kept the rhythm alive. And this is where the idea of unstoppable becomes clear. If an army can keep moving, keep being fed, keep being fueled, keep being resupplied, then stopping it becomes difficult. An opposing force can inflict damage, can slow it down, but the system keeps restoring itself. That restoration is mobility. It's the ability to replace what is lost. It's the ability to shift resources. It's the ability to bring more capability forward. And American mobility made restoration feel almost automatic. One of the most fascinating elements of American wartime production is that it wasn't focused only on combat vehicles. It was focused heavily on support vehicles. This reflects deep strategic understanding. A tank may be a symbol of combat power, but a tank without fuel and maintenance is just steel. A truck, on the other hand, keeps everything alive. The United States produced not only general-purpose trucks, but specialized vehicles, fuel tankers, repair trucks, recovery vehicles, ambulances, engineering vehicles. It created a vehicle ecosystem. And because this ecosystem was standardized and produced at scale, it could be deployed widely. It meant that even in remote areas, forces could have access to support services that kept operations running. This is part of why American operations were often described as well supplied compared to many opponents. Again, this isn't about bragging or triumph. It's a calm recognition of a structural advantage. Structures matter more than moments. Now, to appreciate how mobility shaped weapon effectiveness, consider artillery. Artillery is one of the most powerful tools in modern war, but it consumes ammunition at a high rate. An artillery unit might fire thousands of shells in a short period. Those shells are heavy. They must be transported from factories to ports, from ports to depots, from depots to frontline batteries. This requires trucks. It requires rail. It requires careful planning. Without mobility, artillery becomes limited. With mobility, artillery becomes a constant presence. And American artillery became extremely effective, partly because it was well supplied. That supply depended on trucks. Similarly, tanks require fuel. Tanks consume fuel at a high rate. They need spare parts. They need maintenance crews. They need recovery vehicles. All of these support elements require transport. A tank unit is not just tanks. It is a whole moving community of support vehicles. The United States had the capacity to provide that community. And because it did, its armoured forces could operate with more continuity. They could recover from losses. They could repair and return tanks to service. They could keep moving. In the Pacific, mobility also meant amphibious logistics. You couldn't simply drive a truck across an ocean. You had to load it onto a ship, unload it onto a beach, and then operate it in an environment where roads might be poor or non-existent. This required engineering, bulldozers, bridging equipment, and careful planning. The United States became extremely good at this, creating mobile bases that could be established on captured islands. Trucks moved supplies from beaches inland. Jeeps and small vehicles helped coordinate operations. The mobility system didn't end at the shoreline. It extended into the interior of islands. And as the war progressed, the American ability to set up these logistics systems became more refined. It became faster. It became more routine. And that routine is key. When something becomes routine, it becomes difficult to stop because it no longer relies on improvisation. It relies on established processes. This is another reason American weapons felt unstoppable. The system that delivered them became routine. It became repeatable. It became a conveyor belt of capability. Now, beyond the vehicles themselves, there's also the concept of mechanized logistics. The US didn't only build trucks. It built the organizational capacity to use trucks effectively. That means driver training programs. It means maintenance schedules. It means fuel distribution plans. It means road construction and repair. It means traffic control. It means convoy organization. It means coordination with rail and ports. In other words, mobility was not just hardware. It was doctrine and management. And American forces treated mobility as a strategic priority. They invested in it. They planned around it. They created specialized units to handle it. This gave American commanders an advantage. They could assume that supply would arrive, and because they could assume that, they could plan more ambitious operations. The ability to plan ambitious operations is itself a form of power. It expands what is possible. It changes war from a series of small local struggles into a coordinated campaign of movement and pressure. A mobile force can choose where to apply pressure. It can bypass strong points. It can exploit weaknesses. And the United States, supported by its trucks and vehicles, could apply this kind of pressure in a sustained way. Again, not with reckless drama, but with a steady, methodical accumulation of advantage. It's also worth remembering that mobility had a human impact beyond combat. Trucks and vehicles transported wounded soldiers to medical facilities. They carried food and water. They moved engineering equipment to build shelters, roads, bridges. They improved living conditions. In a long war, these quality of life factors matter. An army that is well fed and medically supported tends to function better. It tends to have lower non-combat losses. It tends to maintain morale more effectively. So mobility contributed to endurance. Endurance is a quiet but essential part of unstoppable. The American war machine didn't just strike, it endured. It sustained itself. And it sustained itself partly because it could move everything it needed to move. Another aspect of American mobility is its effect on allies. Lend-Lease included large numbers of vehicles, especially trucks, sent to allies like the Soviet Union. These vehicles had enormous value because they increased the Red Army's ability to move supplies and troops. In a war fought across vast distances, mobility can change outcomes. Trucks helped support offensives, helped transport artillery and ammunition, helped move forces more quickly. So American mobility wasn't just an advantage for American troops. It became an advantage for the Allied coalition. It spread the American style of mechanized logistics across multiple armies. This is part of why America's weapons felt unstoppable on a global scale. They were not confined to American units. They extended outward through supply and alliance, and that extension magnified their impact. In calm summary, what we see here is that American vehicles, jeeps, trucks, transport systems were not just helpful tools, they were the very mechanism by which American industrial strength became battlefield strength. They allowed weapons to arrive. They allowed repairs to happen. They allowed supplies to flow. They allowed commanders to plan with confidence. They reduced friction. They increased tempo. They increased endurance. And they spread capability across a global coalition. In the end, it's hard to imagine American firepower being as effective without American mobility. The jeep and the truck were not merely accessories to war. They were the quiet engines that kept the entire war machine moving forward, steadily and predictably. And in a conflict where so much depended on sustained operations, that steady movement is one of the clearest reasons American weapons became unstoppable. When people picture American strength in World War II, tanks often appear in the imagination as the most obvious symbol of power: steel, tracks, armoured hulls, big guns, the slow confidence of heavy machinery. But when you look calmly and closely at why American weapons became unstoppable, the tank story is actually less about a single fearsome machine and more about a philosophy. Build a tank that can be produced in huge numbers, repaired quickly, transported reliably, crewed effectively, and kept running without endless downtime. And that philosophy is exactly what shaped the M4 Sherman, the most widely used American tank of the war and one of the clearest examples of how America's industrial approach translated directly into battlefield endurance. The Sherman has been debated and discussed for decades. People compare its armour, its gun, its silhouette, and they often ask whether it was better or worse than the tanks it faced. But tonight, in this slow and soothing documentary tone, we don't need to turn it into a contest of drama or myth. We only need to understand what the Sherman was designed to do and why, in the specific context of a global industrial war, that design approach produced an unstoppable effect. The Sherman wasn't a tank built to be the single best duel fighter in every possible matchup. It was a tank built to be the best system tank. A tank you could make in massive quantities, ship across oceans, support with spare parts, and keep active in the field. And in war, especially war on the scale of World War II, a system tank can be more decisive than a technically superior but fragile or scarce machine, because the system tank stays present, and presence over time turns into strategic dominance. To understand the Sherman's importance, it helps to begin with the reality of modern armoured warfare. Tanks are not just weapons, they are mobile, mechanical ecosystems. They require fuel, they require ammunition, they require maintenance, they require trained crews. They require coordination with infantry, artillery, and air support. A tank that looks impressive but breaks down often is not truly powerful. A tank that can't be shipped and repaired easily is not truly powerful, and a tank that is produced in small numbers can be tactically impressive but strategically limited. The United States recognized these realities and built its armoured forces around them. American planners understood that they would likely have to fight far from home, across oceans, in multiple theatres. That meant tanks had to be moved long distances and then operate continuously under stress. In that context, reliability and maintainability become as valuable as gun caliber. A tank that runs every day creates steady pressure. A tank that's always in the repair yard does not. So the Sherman was designed with reliability in mind, and this design choice made a massive difference over time. The Sherman's mechanical reliability was one of its strongest assets. It was not perfect, no wartime machine is, but it generally earned a reputation for being dependable compared to many opponents. And this matters because tanks that break down cannot influence the battlefield. It also matters because tank breakdowns create logistical burdens. Recovery vehicles, spare parts, repair time. A tank that is easier to maintain reduces these burdens. It keeps the armoured force more operational. It increases what military planners call availability, meaning the proportion of vehicles that are ready for action at any given moment. Availability is a quiet, decisive statistic. Even if an enemy tank might be stronger in a direct duel, if it is frequently unavailable due to mechanical issues or lack of parts, its overall effect declines. The Sherman, supported by American industrial supply, tended to maintain higher availability. That steady availability contributed directly to the unstoppable feeling of American armoured forces. They could keep coming, not because they were invincible, but because enough of them were always ready. Another major advantage was production. The Sherman was produced in enormous numbers, and the ability to produce it in huge numbers was not accidental. It was built into the design philosophy. American tank design favoured manufacturability. That means the tank was engineered so factories could build it efficiently, with standardised components, with processes that could be repeated at scale across multiple production sites. In wartime, this is crucial. If only one factory can build your tank, then output is limited and vulnerable. If many factories can build it, output grows. The United States produced Shermans through multiple manufacturers, which allowed production to ramp up dramatically. And because the tank was standardized enough to be produced widely, it became a stable platform. Stability matters because it allows supply systems to standardize around it. It allows depots to stock common parts. It allows mechanics to train on one primary vehicle. It allows crews to be trained quickly. It allows unit organization to stabilize. This stability and scale created a form of armored continuity that many opponents struggled to match. In practical terms, it meant that when Shermans were lost, replacements could arrive, and replacements didn't arrive as rare treasures. They arrived as steady shipments. That steady replacement capability matters more than most people realize. Tanks are often destroyed in war. They are disabled by mines, mechanical failure, artillery, anti-tank weapons, or air attack. Even if crews survive, the vehicle may be lost. In an army that lacks replacement capacity, these losses accumulate until armoured units become ineffective. In an army with strong replacement capacity, losses can be absorbed and the force remains operational. The United States had the industrial capacity to replace tanks at scale, and the Sherman was the vehicle that made that replacement practical. That's a core reason American armour felt unstoppable. It didn't disappear after a few costly engagements. It kept reappearing. Now, the Sherman's design also reflected the American preference for balanced combined arms. The United States rarely viewed tanks as lone dueling machines. American doctrine tended to emphasize cooperation between tanks, infantry, artillery, and air power. That means tanks did not have to solve every problem alone. If a German heavy tank threatened an area, the response might involve artillery, airstrikes, tank destroyers, infantry anti-tank weapons, and coordinated maneuvers. In that context, the Sherman's job was not always to fight a one-on-one duel at maximum disadvantage. Its job was to support the combined arms team. It was a tool in a larger system. And because the American system was strong, thanks to logistics, mobility, and industrial output, the Sherman could be effective even when facing technically superior opponents. It could be used aggressively where it had advantages. It could maneuver. It could exploit breakthroughs. It could support infantry. It could respond quickly. And because it was available in large numbers, it could be concentrated. Concentration matters. Even if one tank is less formidable, multiple tanks working together can create overwhelming pressure, especially when supported by artillery and air power. So the Sherman's strength was not just its own specifications. Its strength was the environment it existed in, an American war machine that provided fuel, maintenance, replacements, and support fire. This is the essence of unstoppable weapons. They belong to an unstoppable system. Another key element was transportability. This might seem like a mundane point, but it's deeply important. The United States had to ship tanks across the Atlantic and the Pacific. A tank that is too heavy can create shipping constraints. It takes up more cargo space. It requires stronger ships and heavier landing craft. It requires more fuel to transport. It can limit where it can be deployed. The Sherman was heavy, yes, but it was manageable within the logistical reality of American global operations. It could be shipped in large numbers. It could be loaded and unloaded. It could be transported to battlefields without excessive complication. This logistical practicality made it more useful strategically. It meant American armoured forces could appear in multiple theatres. It meant the United States could support allies as well, sending Shermans to Britain and other nations. It meant armoured formations could be built and sustained overseas. In war, deployability is as important as performance. A tank that is excellent but cannot be deployed widely is limited. A tank that is good and can be deployed everywhere becomes decisive. The Sherman was decisive in that way. Now, If we calmly address the question of protection and firepower, it's true that the Sherman faced challenges, especially as the war progressed and German anti-tank weapons improved. The Sherman's armour and gun were sufficient in many situations, but not always ideal in direct encounters with heavier German tanks like the Panther and Tiger. This has led to criticism and debate. But again, the key is context. The Sherman's role wasn't to be the heaviest tank on the battlefield, it was to be the most sustainable tank for American operations. The United States did not approach tank warfare as a quest for the biggest armour and biggest gun alone. It approached tank warfare as a sustained campaign tool, an armoured force that could keep operating day after day. And for much of the war, the Sherman's gun was effective against many opponents, and its mobility allowed tactical flexibility. Also, the United States did upgrade and improve the Sherman over time, introducing variants with better guns, improved armour features, and other refinements. These upgrades show again the American advantage of iterative improvement at scale. A stable platform can be upgraded. A mass-produced platform can incorporate refinements. And when those refinements spread across thousands of vehicles, they change outcomes. Another part of the Sherman story is crew effectiveness. A tank is not just a machine, it is a human system. A well-designed tank supports its crew. It provides workable internal space. It offers reliability. It allows crews to focus on fighting rather than constant mechanical crises. The Sherman's ergonomics and mechanical reliability generally supported crew performance. American tank crews also benefited from training systems that expanded rapidly during the war. This training was supported by standardization. When your primary tank model is consistent, training becomes more efficient. Crews learn one system, mechanics learn one system. Spare parts supply becomes predictable. This again contributes to readiness. Readiness is what gives armies consistent power, and consistent power is what feels unstoppable. It is also important to note how the Sherman fit into the larger American maintenance and recovery system. In many armies, a disabled tank might be abandoned if recovery is too difficult or if spare parts are unavailable. The United States invested heavily in recovery and repair. It had recovery vehicles, it had maintenance units, it had spare parts pipelines. That meant damaged tanks could often be recovered, repaired, and returned to service. This increased the effective size of the armoured fleet over time. It also reduced the impact of battlefield losses. A tank knocked out might not be permanently lost. It might return after repair. This kind of resilience is a powerful advantage. It means the enemy must work harder to permanently reduce your strength. It means you are harder to wear down. It means your force can survive attrition better. Attrition is one of the key realities of industrial war. The Sherman, within the American maintenance ecosystem, was built to withstand attrition better than many opponents. It was a tank you could keep alive. And keeping machines alive is one of the quiet keys to winning long wars. Another dimension is the Sherman's adaptability. Because it was produced in huge numbers and had a stable design, it became a platform for modifications and specialized variants. Shermans were adapted for different roles: flamethrower tanks, bridge layers, mine-clearing variants, armored recovery vehicles, and more. This flexibility increased operational capability. It meant the tank platform could solve multiple problems. It reduced the need to create entirely new vehicles for each specialized task. It also meant that logistics could remain centered around a familiar base vehicle. This is a very American solution. Take a core design, then adapt it broadly. In an industrial war, adaptable platforms are incredibly valuable. They create efficiency. They reduce complexity. They speed up problem solving. And they allow rapid response to battlefield needs. This is another way American weapons became unstoppable. They could adapt without slowing production drastically. A final point worth reflecting on is the relationship between tanks and American supply. Tanks consume fuel at a high rate. In many armies, fuel was a constant limiting factor. German armoured forces, especially later in the war, often faced fuel shortages. Fuel shortages reduce training, reduce operational tempo, and reduce the ability to exploit breakthroughs. The United States, with its huge oil production and refining capacity, could supply fuel more effectively, and its trucks could deliver it. That means Shermans could keep moving. In a calm mechanical sense, fuel is the lifeblood of armoured warfare. Without fuel, tanks are stationary. With fuel, tanks become mobile firepower. The American fuel advantage, combined with truck mobility, meant Shermans could operate more consistently. Consistent operation again contributes to unstoppable momentum. Over time, a force that keeps moving gains initiative. It forces the opponent to react. It can choose when to engage. It can exploit opportunities. It can retreat and reposition. It can surround. It can support infantry. It can pursue. Stationary forces lose flexibility. The Sherman, powered by American fuel logistics, help maintain flexibility, and flexibility in war is strength. So when we step back and ask why American weapons became unstoppable, the Sherman gives us a clear answer. It was a weapon designed not for isolated glory, but for sustained effectiveness. It was made to be produced in enormous numbers, shipped across oceans, repaired and maintained efficiently, upgraded over time, and used within a combined arms system supported by strong logistics. In that environment, the Sherman didn't need to be perfect. It needed to be present. It needed to keep running. And it needed to be supported. And because it was all of those things, it helped American armoured forces apply steady pressure across campaigns, turning industrial scale into battlefield momentum. The Sherman was the embodiment of a larger truth. In a global industrial war, the unstoppable weapon is often not the most advanced weapon, but the weapon that belongs to the most resilient system. Air power in World War II is sometimes told as a story of daring pilots and dramatic dogfights. And those moments did happen. But if we want to understand, calmly and factually, why American weapons became unstoppable, we have to look at aviation through a different lens. Aviation as a system of production, range, reliability, and repeatable quality. The United States didn't become dominant in the air simply because it built a few excellent planes. It became dominant because it built enormous fleets of aircraft, trained crews to use them, supplied them with fuel and parts, and kept them flying in sustained operations across huge distances. And that last part, distance, is especially important because in World War II, the shape of the war was defined not only by battlefields, but by geography. The Atlantic Ocean separated North America from Europe. The Pacific Ocean stretched even farther, and the ability to operate aircraft over long ranges, to escort bombers, to patrol oceans, to strike targets deep behind front lines, required not just clever design, but industrial stamina. Aircraft require constant maintenance. Engines wear out, components fail, weather damages airframes, runways degrade, pilots and crews need training cycles. So the true power of aviation isn't a single plane in the sky, it's the ability to keep planes in the sky day after day, month after month, as part of a larger machine. The United States mastered this, and in doing so, it made its air power feel relentless. One of the clearest reasons American aviation became unstoppable was mass production itself. Aircraft are complicated. Compared to rifles or trucks, they demand high precision, complex materials, and carefully managed assembly. They contain engines with many moving parts, aircraft instruments, radios, fuel systems, and aerodynamic structures that must be built accurately. A country might build excellent aircraft in small quantities, but the war demanded far more than excellence. It demanded volume. The United States, drawing on its industrial base and the assembly line mindset, developed the capacity to mass-produce aircraft at a scale unmatched by most opponents. This doesn't just mean more planes. It means more everything. More engines, more propellers, more landing gear assemblies, more radios, more machine guns, more bombs, more fuel tanks. It means entire ecosystems of suppliers feeding into aircraft factories. And when that ecosystem stabilizes, output becomes enormous. Factories become synchronized. Components arrive in steady flows. Workers specialize. Quality control becomes systematic. The result is a kind of industrial rhythm, a steady pulse of production that can replace losses and expand fleets simultaneously. That ability to replace losses is one of the most important reasons American air power became unstoppable. In air warfare, losses are inevitable. Accidents happen, planes are shot down, weather claims aircraft, mechanical failures occur. If a nation cannot replace losses quickly, its air power declines. If it can, its air power remains strong or even grows. The United States could replace losses. That meant American commanders could sustain operations without fearing that one costly month would permanently reduce strength. It meant the air war could be fought as a long campaign rather than a fragile, short-lived burst of effort. And this kind of resilience changes everything. It turns air power into a constant pressure rather than a temporary advantage. Another major factor was the American focus on engines. A plane's performance is often discussed in terms of speed and maneuverability, but the real foundation of aviation power is engine reliability. A plane with a powerful but unreliable engine becomes a risk. It spends time grounded. It suffers accidents. It requires excessive maintenance. In wartime, engine reliability is not a luxury. It is the difference between an air force that grows and one that bleeds itself dry through wear. The United States invested heavily in building reliable aircraft engines and producing them at scale. Companies like Pratt and Whitney and Wright Aeronautical became essential not just as manufacturers, but as pillars of the war effort. American engines powered fighters, bombers, transports, and patrol planes, and their reliability mattered because it reduced mechanical attrition. If fewer engines fail unexpectedly, fewer aircraft are lost without enemy action. That means more aircraft remain available for missions. More aircraft available means more sorties flown. More sorties flown means greater operational influence. Over time, that influence compounds. It becomes a steady weight pressing down on the enemy's ability to function. Engine production also reinforced the American advantage in standardization. When you build engines at scale with consistent design families, you make maintenance easier. Mechanics become familiar with systems. Spare parts can be stocked more predictably. Repair depots can specialize. Aircraft availability increases. The war machine becomes smoother. Again, this is unstoppable not because it is exciting, but because it is organized. Another crucial reason American aviation became unstoppable was range. Range is one of the defining characteristics of the Second World War, especially in the Pacific, where distances between islands and targets could be enormous. Even in Europe, range mattered because of the need to escort bombers and strike deep targets. An aircraft that can only fly a short distance limits strategic options. An aircraft with long range expands the map. It allows pressure to be applied where it matters most. And American aviation, aided by both aircraft design and logistical support, developed the ability to operate at these extended distances. This is where the P-51 Mustang becomes a central symbol. The Mustang was not the only important American fighter, but it represents a key turning point, the ability to escort bombers deep into enemy territory. Bomber forces without escort are vulnerable. Escort fighters protect bombers by deterring enemy interceptors. If bombers can reach targets and return in greater numbers, the bombing campaign becomes more sustainable and more effective. The Mustang's range, especially when combined with drop tanks, helped make deep escort possible. This had major consequences in the air war over Europe because it reduced bomber losses and increased the effectiveness of strategic bombing. But again, the deeper reason this mattered is system endurance. The United States didn't just build Mustangs, it built them in huge numbers. It trained pilots, it provided spare parts, it supplied fuel, it integrated the Mustang into an air campaign supported by logistics. That integration turned a good aircraft into a strategic force. Another dimension of American air power is the way aircraft were treated as part of an industrial process. Aircraft were designed not only for performance, but also for production. They were engineered to be built efficiently. Assembly lines were optimized. Sub-assemblies were produced in different locations and shipped to final assembly plants. This distributed production increased output and reduced vulnerability. It also allowed specialization. One facility might focus on wings, another on fuselages, another on engines. When these streams converge efficiently, aircraft production accelerates. And because America had strong transportation networks, railways, roads, ports, it could move these components effectively. This is a subtle but important point. Mass aircraft production depends on transportation. If you cannot move components efficiently, you cannot maintain assembly flow. American logistics supported aircraft production itself, not just the deployment of aircraft. This created a reinforcing loop. Industry supports logistics, logistics supports industry, and together they create continuous output. Continuous output creates continuous operational power. Another factor is training, both of air crew and of ground crew. Air forces require vast numbers of specialists: pilots, navigators, bombardiers, gunners, radio operators, mechanics, armourers, fuel handlers, meteorologists, and more. The United States created training pipelines to produce these people at scale. Training became standardized, procedures became repeatable. Airfields across the country became training centers. This meant that as aircraft production increased, the personnel to operate and maintain those aircraft also increased. This is important because aircraft alone do not create air power. Air power is the combination of aircraft and trained personnel. The United States expanded both in parallel. This parallel expansion is one of the most impressive aspects of the American war effort. Many nations could not do this at the same scale because they lacked resources or were under attack. The United States, protected by oceans, could train and produce simultaneously, and that created a steady increase in capability over time. Time, again, becomes a weapon. If your capability grows month after month, while the enemy's capability stagnates or declines, the balance shifts steadily. That steady shift is part of the unstoppable feeling. American air power didn't just spike, it grew. Another crucial element is maintenance and spare parts. Aircraft require constant attention. They are not like rifles that can function with minimal upkeep. Aircraft engines must be serviced. Airframes must be inspected. Damage must be repaired. Instruments must be calibrated. The United States built an enormous maintenance and supply system for aviation. Spare engines were shipped, parts were stockpiled, maintenance units were trained, repair depots were established in theatres of war. This meant that aircraft could be repaired and returned to service. It reduced the number of aircraft permanently lost due to damage. It increased operational availability, and it allowed air campaigns to continue at high tempo. High tempo in air war means frequent sorties. Frequent sorties mean constant pressure. Pressure wears down the enemy. It disrupts production. It forces dispersal. It strains air defences. It reduces mobility. It makes daytime movement risky. Over time, constant pressure changes behaviour. This is one of the deepest strategic effects of sustained air power. It alters the enemy's rhythm. It forces them into defensive patterns. The United States, by sustaining sorties at scale, created this kind of strategic pressure, and because it could keep doing it, the pressure felt unstoppable. American naval aviation also deserves attention here, because it combined aircraft production with ship production, creating mobile airfields that could project power across oceans. Aircraft carriers were not just ships, they were floating bases. They required aircraft, pilots, fuel, munitions, maintenance crews, and escort fleets. The United States expanded carrier aviation dramatically in the Pacific. This expansion depended on shipbuilding and aircraft production both occurring at massive scale. It also depended on training pipelines and logistics. Carriers could operate far from home because supply ships followed them. Fuel could be delivered, aircraft could be replaced, damaged ships could be repaired. This is where the American war machine becomes especially impressive. It created mobile systems of power. A carrier task force is a system. It includes ships, aircraft, logistics, and coordination. The United States produced and sustained these systems. And because it could produce multiple task forces, it could apply pressure in multiple places. That flexibility is a form of dominance. The enemy cannot concentrate everywhere, but the United States could appear with air power in one place, then another, sustaining operations. Again, this is not dramatic here, it's structural. Another important dimension is the role of transports and logistics aircraft. Fighters and bombers are the glamorous part of air power, but transports are essential. The United States produced large numbers of transport aircraft that moved supplies and personnel. This increased operational flexibility. It allowed rapid movement of critical parts, commanders, medical supplies, and more. In a global war, the ability to move items quickly through the air can solve urgent problems. It reduces delays, it increases coordination, it keeps operations running smoothly. And again, smooth operations are hard to stop, they create momentum. Finally, we can calmly consider what happens when you combine all these factors: mass production, reliable engines, long range, standardized maintenance, large training pipelines, and logistical support. You don't just get an air force, you get an air system. And an air system, once established, becomes very difficult to defeat quickly. Even if an enemy shoots down aircraft, replacements arrive. Even if aircraft wear out, engines are replaced. Even if airfields are damaged, engineers repair them. Even if pilots are lost, training pipelines continue. The system absorbs losses and continues functioning. That absorption of losses is the hallmark of unstoppable power in industrial war. The United States created an air system that could endure, it could learn, it could adapt, it could grow. And because it could do all of those things at once, American air power became a constant presence, steady, methodical, and persistent. It wasn't only a weapon in the sky, it was the industrial sky itself, built in factories far away, sustained by supply lines, maintained by countless mechanics, and operated by trained crews, all working together so that day after day, the engines kept turning and the aircraft kept rising, carrying with them the quiet proof that American weapons were not just designed to win battles, but designed to keep winning without running out of breath. Naval power in World War II is often described in terms of great battles and famous ships, and those moments certainly shaped the course of the war. But if we want to understand, in a calm and factual way, why American weapons became unstoppable, we have to look at the Navy the way the United States itself learned to look at it, as a system, not just a fleet. A ship is powerful, yes, but a ship becomes truly decisive only when it is part of an ecosystem that can build it quickly, crew it efficiently, fuel it reliably, supply it consistently, repair it repeatedly, and replace it when it is lost. And this is precisely where American naval power became so overwhelming. The United States didn't only build warships. It built shipyards that built shipyards, training systems that produced crews in massive numbers, logistics chains that stretched across entire oceans, and standardized methods of construction that turned shipbuilding into something closer to a disciplined industrial process than traditional craftsmanship. The American Navy became unstoppable because it became renewable. It became a force that could regenerate itself faster than an enemy could wear it down. And in a war fought across seas and oceans, renewal is one of the greatest strategic advantages a nation can have. When you think about the Pacific War especially, the ocean is not simply a background, it is the battlefield. And the distances involved are enormous. Ships travel for days or weeks. Fleets operate far from home ports. Fuel consumption becomes a strategic constraint. Maintenance becomes a constant requirement. Supply becomes a daily necessity. So the power of a navy is not only its guns and torpedoes, it is its ability to stay at sea, to move freely, and to keep operating even after suffering losses. The United States, drawing on its industrial strength, mastered this kind of sustained naval warfare. It built a navy that could operate continuously, supported by a supply system so extensive that it effectively turned the ocean into an extension of American industrial space. A warship thousands of miles away could still be fueled, supplied, and repaired. And when you can do that, your naval power expands from a coastal defense tool into a global instrument. That is a major reason American weapons became unstoppable. The United States could bring power anywhere and keep it there. One of the quiet foundations of this was merchant shipping. Warships may win battles, but merchant ships sustain wars. They carry fuel, ammunition, food, vehicles, aircraft parts, and every other essential item. Without merchant shipping, armies cannot be supplied and fleets cannot operate. Early in the war, German submarines targeted merchant ships in the Atlantic, aiming to choke off supply to Britain and disrupt American support. The United States responded not only by hunting submarines but by building ships at an astonishing pace. Liberty ships became the symbol of this, They were not elegant. They were not glamorous. They were designed for one purpose: carry cargo reliably and be built fast. And they were built in huge numbers. This is the system nature of American naval power. When an enemy tries to reduce your shipping, you don't only fight back at sea, you outproduce the losses. You make the problem unsustainable for the attacker. If submarines sink ships, but you build ships faster than they can be sunk, then the attack cannot achieve its goal. It becomes a losing strategy. This approach reflects the broader American industrial logic. Don't only defend, overwhelm the attrition equation. The Liberty ship program and other mass shipbuilding efforts changed the war's logistical reality. It meant that supplies could continue flowing even under attack. It meant Britain could be sustained. It meant American forces could deploy. It meant the Soviet Union could receive aid. In this way, shipbuilding was not separate from combat. It was combat. It was a strategic act that shaped the possibility of victory. And because the United States could build these ships in standardized ways, with prefabrication and industrial scheduling, shipyards became production engines. This is one reason American naval power felt unstoppable. It wasn't only about having a fleet, it was about having the ability to replace and expand a fleet continuously. Another major area was escort vessels and anti-submarine warfare. Convoys required protection. Merchant ships needed escorts. The United States and its allies produced destroyer escorts, corvettes, and other vessels designed to hunt submarines and protect shipping. These ships weren't always celebrated in popular memory, but they were crucial. They enabled the safe movement of cargo across the Atlantic. They reduced shipping losses. And they created a strategic environment where German submarine warfare could not achieve decisive results. Again, this is not dramatic, it is systematic. It is the slow tightening of a net, and that net, supported by industrial output, made American and Allied supply lines more secure. Secure supply lines are the foundation of unstoppable power. Now, beyond merchant shipping and escorts, the most iconic symbol of American naval power in World War II is the aircraft carrier. The carrier represented a shift in naval warfare. Instead of battleships as the primary source of naval striking power, aircraft became the main weapon. The carrier is not simply a ship, it is a mobile airbase. It carries fighters, bombers, torpedo planes. It carries fuel for those planes. It carries munitions. It carries spare parts and maintenance crews. And it allows air power to be projected far from land. The United States recognized the carrier's importance and produced carriers at a scale that reshaped the war. It built fleet carriers and escort carriers. Fleet carriers were powerful and central to major operations. Escort carriers, smaller and more numerous, provided aircraft support for convoys and amphibious operations. This mix is important. It shows the American focus on systems and coverage. The United States didn't rely only on a few large ships. It created layers of capability. Big carriers for major strikes, escort carriers for protection and support. This layered approach made American naval aviation flexible. Flexibility is another element of unstoppable power. A flexible force can respond to threats, adapt to changing conditions, and apply pressure in multiple places. And because the United States had the industrial output to build many carriers, it could sustain operations even after losses. This is crucial in carrier warfare. Carriers are valuable. Losing them can be devastating if replacements are not available. The United States, because it could build more, could absorb losses better than many opponents. This created a strategic asymmetry. It meant the U.S. Navy could take risks and continue operating. It meant that the long-term trend favored American expansion. Another key point is shipbuilding tempo and modular construction. American shipyards developed methods to build ships quickly using prefabricated sections. Workers could assemble parts of ships in parallel, then combine them. This reduced build time. It also allowed shipbuilding to become more like assembly line production. Once again, the American industrial mindset appears. It's the same logic that produced trucks and aircraft. Standardize, repeat, scale. Ships are far larger than trucks, but the principle holds. When you can treat shipbuilding as a repeatable industrial process, you can expand output dramatically. And output changes wars. It changes strategic choices. It changes the enemy's options. When an enemy knows you can replace ships quickly, their calculus changes. Their attacks must be more decisive, more perfect. And perfection is hard in war. The United States didn't require perfection, it required persistence. And persistence is hard to defeat. Naval power also depended heavily on fuel and logistics, perhaps more than any other branch. Ships consume enormous quantities of fuel. Fleets require constant resupply. In the Pacific, the United States developed an extraordinary underway replenishment system, using oilers, supply ships, and tenders to support fleets at sea. This meant fleets did not always have to return to ports. They could stay on station. They could operate continuously. They could keep pressure on Japanese positions. This is a major reason American naval power became unstoppable. It extended endurance. Endurance at sea means strategic initiative. A fleet that can stay at sea can control when and where engagements occur. It can choose when to strike. It can maintain blockade pressure. It can support amphibious operations. If the enemy must return to port more often due to logistics limits, they lose flexibility. The United States reduced its own need to retreat from operational areas by building logistics into the fleet. That is a profound systems advantage. It turns the ocean into a highway rather than a barrier. Another crucial part of the American Navy was amphibious warfare. The United States carried out massive amphibious operations in both the European and Pacific theaters. Amphibious warfare demands specialized vessels, landing craft, amphibious tractors, transport ships, and support vessels. It demands coordination between Navy, Air Forces, and ground forces. It demands planning. It demands supply. The United States produced landing craft and amphibious shipping in enormous quantities. This allowed it to project ground forces onto beaches repeatedly, on islands, in Europe, across vast distances. Amphibious capability is essentially the ability to create a battlefield anywhere along a coastline. That is a form of strategic freedom. The enemy cannot defend everywhere. They must guess where the landing will come. They must spread forces. And spreading forces reduces strength. So, American amphibious capacity forced opponents into difficult defensive positions. It also allowed the United States to choose routes of advance. In the Pacific, island hopping depended on amphibious mobility. In Europe, operations like Normandy depended on it. This amphibious power wasn't only bravery and planning, it was industrial output. It required ships and landing craft in huge numbers. It required specialized vehicles. It required supplies. And because the United States could produce and sustain these assets, amphibious operations could happen again and again. That repetition is part of unstoppable power. The American Navy also benefited from radar, communications, and coordinated fleet doctrine. Technology and organization combined. Radar improved detection and night fighting capability. Communications improved coordination. Carrier task force doctrine evolved. Anti-aircraft defenses improved. Damage control procedures improved. And the United States had the training systems and institutional capacity to spread these improvements across the fleet. When one ship learned something, the fleet could adopt it. This learning capacity is another signature of unstoppable systems. They improve as they operate. They do not remain static. The United States created feedback loops between combat experience and training, between engineering and field operations. This meant the Navy became more effective over time, and because shipbuilding continued simultaneously, new ships could incorporate lessons learned. This is an extraordinary advantage. It means the fleet doesn't just grow, it becomes smarter, it becomes more resilient, it becomes more efficient. In contrast, opponents under heavy pressure might struggle to implement improvements across the fleet, especially if production and training systems are constrained. Another aspect of naval power is repair. Ships in war are damaged, not always sunk, but damaged. A navy that cannot repair ships quickly loses strength. A navy that can repair ships returns them to service and maintains operational pressure. The United States invested heavily in ship repair capability, including mobile repair ships and forward repair bases. This meant that damaged ships could be patched and returned to action without returning all the way to distant home ports. Again, this extends endurance. It keeps fleets strong. It reduces downtime. It contributes to the unstoppable feeling because the fleet seems to recover quickly. It absorbs damage and continues. Finally, when we calmly step back and see the American Navy as a whole, what we see is not simply a collection of powerful ships. We see a production and logistics organism. Merchant ships feed the system. Escort vessels protect the feed. Carriers and warships project power. Repair ships keep units alive. Oilers extend endurance. Landing craft enable amphibious warfare. Radar and communications improve coordination. Training pipelines replenish crews, and shipyards keep building more. This organism is what made American naval power unstoppable. The enemy could sink ships, and ships would be replaced. The enemy could fight battles, and the fleet would recover. The enemy could defend islands, and amphibious forces would appear elsewhere. The enemy could attempt to sever supply lines, and the United States would protect and expand them. The system kept growing. It kept learning. It kept moving. And in a war where the sea was a primary battlefield, that steady growth and resilience became a decisive force. The American Navy was not unstoppable because it never suffered. It was unstoppable because it could endure suffering and keep functioning. It could repair itself. It could replace itself. It could supply itself. And because it could do those things on an industrial scale, American naval power became one of the clearest examples of how America's World War II weapons weren't just strong, they were sustained, supported, and continuously renewed, until the weight of that renewal shaped the outcome of the war. One of the calm truths about World War II is that while battles are often remembered as moments of shock and intensity, the actual outcome of the war was shaped just as much by quieter forces planning, engineering, and the steady movement of ideas from laboratories into factories and from factories into the field. And if we're asking why America's weapons became unstoppable, it isn't enough to say industry or scale, because behind industry and scale there was something else that made American production especially powerful. The United States developed an unusually effective pipeline between science, research, and mass manufacturing. In other words, it wasn't just good at building things, it became good at learning, improving, and translating innovation into usable, repeatable battlefield advantage. This is important because war creates constant problems, and the side that can solve problems the fastest, then distribute the solution widely, gains a compounding advantage. That advantage doesn't appear all at once. It builds gradually, like a tide. And by the mid to late war years, the United States wasn't only fielding more weapons than its opponents. It was fielding weapons that increasingly benefited from smarter fuses, better detection systems, improved coordination, and scientific advances that reduced waste and increased effectiveness. Some of these innovations were subtle, some were dramatic, but what they shared was that they were integrated into a mass production system rather than remaining isolated experiments. That is a key reason they became unstoppable. Once an innovation enters mass production, it stops being rare and becomes part of the environment. And when it becomes part of the environment, it shapes outcomes quietly, again and again. One of the best examples of this kind of scientific industrial advantage is radar. Radar existed before World War II, but the war accelerated its development and deployment dramatically. Radar changed the nature of detection. It allowed forces to locate aircraft and ships beyond visual range, often at night or in poor weather. This is not merely a technical improvement. It's a transformation of awareness. Awareness in war is power. If you can detect the enemy earlier, you can prepare, you can intercept, you can reposition, you can reduce surprise, and surprise is one of the deadliest advantages in combat. Radar reduced surprise. It made the battle space more visible, and in naval and air warfare especially, this visibility became decisive. The United States, in cooperation with allies like Britain, expanded radar development and then produced radar systems at scale. That's the key. Development alone is not enough. A nation can invent radar and still fail to deploy it widely if production is limited. The United States could deploy radar widely. Ships carried radar. Aircraft carried radar in some cases. Ground stations used radar to coordinate defences. This widespread deployment meant that radar wasn't just a specialised tool, it became an institutional capability. And, because it was widespread, it created consistent advantages. Improved night fighting, better interception, better fleet coordination, better defence against air attacks. Over time, these consistent advantages reduced losses and increased operational effectiveness. Reduced losses are a quiet form of power. They preserve strength. They allow sustained operations. And sustained operations are what unstoppable systems rely on. Another innovation that shows the American science production pipeline clearly is the proximity fuse. This is one of those inventions that doesn't get the same popular attention as a famous aircraft or tank, but it had a powerful impact because it improved the effectiveness of anti-aircraft fire and certain artillery uses. Traditionally, an anti-aircraft shell had to explode at the right point in space to damage an aircraft. That required either direct hits or carefully timed fuses. Timing a fuse correctly is difficult under combat conditions, especially against fast-moving aircraft. The proximity fuse, in a calm and practical sense, was a solution to this problem. It allowed a shell to detonate when it came near a target, increasing the chance of producing damaging fragments within effective range. The effect of this invention was not dramatic in a cinematic way, but it was decisive in a statistical way. It increased the probability that anti-aircraft fire would be effective. Increased probability means fewer enemy aircraft surviving attacks. It means fewer successful bombing or kamikaze strikes. It means fewer ships damaged. It means fewer crews lost. And when you reduce losses, you preserve operational capability. Proximity fuses were especially useful in defending ships against air attacks and in the Pacific theater, where Japanese aircraft posed major threats to fleets. This mattered greatly. But once again, the reason this innovation mattered so much is that the United States could produce it at scale. The proximity fuse was not a simple device. It required miniaturized electronics that could withstand the shock of firing and function reliably. This is an engineering and manufacturing challenge. Many nations struggled with similar challenges. The United States, with its industrial electronics capacity and its ability to coordinate research with production, could overcome these obstacles. And because it could field proximity fuses widely. It turned a scientific breakthrough into a practical defensive advantage across fleets. That is the American pattern. Innovation becomes mass capability. Another area where this pattern appears is in communications and coordination technology. Modern war requires communication. Units must coordinate. Aircraft must be guided. Ships must operate in formations. Ground forces must request artillery support. Supply movements must be scheduled. The United States produced huge numbers of radios and communication devices, and importantly, it improved and standardized them. A radio is not only hardware, it is training, frequencies, procedures, encryption, maintenance. The United States built an entire communications culture at scale. This improved coordination. Improved coordination increases efficiency. Efficiency reduces waste, and reduced waste increases endurance. This is another quiet loop. Good communication reduces unnecessary losses, improves response times, and allows forces to concentrate power more effectively. It makes operations smoother. Smoother operations feel unstoppable because they don't stall as often. They don't break down into confusion. They keep moving forward. Now, there is one scientific industrial project that stands above all others in World War II, the Manhattan Project. It was extraordinary in scale, secrecy, and complexity. But in the context of our calm documentary narrative, we can treat it as one element of a broader pattern rather than a dramatic centerpiece. The Manhattan Project demonstrates the American ability to mobilize science and industry together. It involved universities, laboratories, engineers, enormous industrial facilities, and coordination across many disciplines. It also involved unprecedented funding and management. Regardless of moral debates, which are real and complex, the Manhattan Project shows something structurally important. The United States could take a cutting-edge scientific theory and turn it into a functional weapon through industrial capacity. That transformation required not only brilliant scientists, but also engineers, machinists, chemists, metallurgists, and supply chains. It required building entire facilities to enrich uranium and produce plutonium. It required quality control. It required precision. And it required the organizational ability to keep all these parts aligned. From the perspective of unstoppable capability, the project reveals that American power extended beyond conventional manufacturing. It could manufacture at the edge of human knowledge. And even if this was a unique case, it reflected a broader national strength, a deep reservoir of scientific talent, and an industrial environment capable of supporting that talent at scale. But even outside such extraordinary projects, the American research and development pipeline influenced many conventional weapons and systems. Consider aircraft improvements. Wartime research led to better aerodynamics, improved engine performance, more reliable components, and better production methods. Research improved metallurgy, creating stronger or lighter parts. Research improved lubricants and fuels, affecting engine performance and endurance. Research improved explosives and propellants, influencing artillery and bombs. Research improved medicine and logistics, affecting troop endurance. All of these improvements might seem separate, but in war they interact. If engines are more reliable, aircraft availability increases. If explosives are more effective, fewer bombs might be needed for certain effects. If logistics is improved, operations can be sustained longer. And because the United States could spread these improvements across a massive production base, it gained compounding benefits. This is a key concept, compounding. In finance, compounding is growth on growth. In wartime systems, compounding is improvement on improvement. A slightly better engine design produces more reliable flights. More reliable flights allow more missions. More missions produce more experience. More experience produces better tactics. Better tactics reduce losses. Reduced losses preserve trained crews. Preserved trained crews increase effectiveness. The system grows stronger over time. That is compounding. And American research production integration allowed compounding to happen faster. Another important part of this pipeline was the organizational structure of wartime research contracts. The U.S. government funded research and development heavily, working with private companies, universities, and laboratories. This created a network. Innovations could move from one node to another. A university might develop a concept, a company might refine it, a military testing center might evaluate it, then production might be scaled. This networked approach allowed specialization. It also allowed speed. Instead of relying on a single central research body, the U.S. could mobilize many institutions. This decentralized power is a form of resilience. If one effort failed, others could succeed. If one design had issues, alternatives could be pursued. And because funding and demand were enormous, progress could be rapid. Again, rapid progress becomes unstoppable when it is paired with mass manufacturing. It means advantages don't remain theoretical, they become real. There's also a subtle point about American industrial culture. It valued practical engineering. It valued solving problems in ways that could be manufactured. Some nations were extremely strong in theoretical science, others in specialized engineering. But the American wartime system excelled at translating ideas into standardized products. This translation process requires a particular kind of talent: manufacturing, engineering, quality control, production planning. It also requires a willingness to compromise between ideal performance and practical production. The United States was often willing to make these compromises in smart ways. It aimed for solutions that worked reliably and could be built in huge numbers, rather than solutions that were perfect but too difficult to produce. This is why some American innovations didn't look as exotic as some German wonder weapons, but they were more widely deployed and more consistently supported. The comparison is useful here because it highlights what unstoppable really means. A rare advanced weapon can inspire fear, but it cannot reshape the war if it remains rare. A widespread reliable weapon can reshape everything. American R&D was often focused on giving broad forces practical advantages rather than giving a small number of units extraordinary tools. That preference aligns with the American industrial style. Democratize capability through mass production. Spread advantage across the entire force. That is how you create persistent pressure. Persistent pressure is hard to resist. Now, radar and proximity fuses are excellent examples, but we can also mention another quiet scientific advantage: quality control and statistical methods. The war pushed many industries to adopt more systematic quality control approaches. This meant that as production scaled, quality didn't collapse. Maintaining quality in mass production is difficult. If quality drops, reliability drops. If reliability drops, operational losses increase. If operational losses increase, strength declines. The United States used industrial management techniques to keep quality stable. This is not exciting, but it is powerful. It means aircraft engines keep running. It means bombs function properly. It means radios work. It means vehicles last longer. Each of these small reliability improvements reduces waste and increases endurance. And again, endurance is one of the key markers of unstoppable systems. Endurance means you can continue operating even when you take losses. Endurance means you can maintain pressure. Endurance means you can wait out an opponent's weaknesses. In war, waiting is not passive. Waiting while applying pressure is strategy. And the United States had the endurance to do that. Finally, when we calmly summarize this section, what stands out is a simple idea. America's wartime strength wasn't only in how much it produced, it was in how well it could connect knowledge to production. It could take a scientific breakthrough and turn it into thousands, sometimes millions, of usable devices that could be deployed widely and maintained reliably. It created feedback loops where combat experience informed improvements, and improvements flowed back into mass production. Over time, this created a steady rise in effectiveness. The American war machine didn't just stay strong, it became stronger. It became more coordinated. It became more accurate. It became more resilient. And because it could spread these advantages across fleets, armies, and air forces, the enemy didn't face isolated pockets of innovation. They faced an entire environment that was gradually becoming more difficult to survive within. That is what makes this pipeline so important to our theme. In an industrial war, unstoppable isn't about one miraculous weapon. It's about the system's ability to keep solving problems and distributing the solutions. The United States, through its blend of research talent, industrial capacity, and organizational coordination, built a learning war machine. And a learning war machine, one that grows, adapts, and spreads its improvements, can become, over time, one of the most unstoppable forces in history. When you look calmly at why American weapons became unstoppable in World War II, the most important theme that keeps appearing is not raw strength or dramatic moments, but systems. Systems that could endure, adapt, and keep functioning even under constant strain. And in the final stretch of this story, one of the most important systems of all is the American learning machine. The ability to train at scale, gather feedback from combat, improve doctrine, and then spread those improvements through the entire force with steady efficiency. This is not the kind of power that makes headlines, but it is the kind of power that wins long wars. Because the truth is that even with excellent weapons, an army can still be ineffective if it cannot coordinate them, if it cannot maintain them, and if it cannot adapt its tactics to changing circumstances. The United States became unstoppable not only because it produced huge quantities of equipment, but because it built an organization capable of using that equipment intelligently and consistently. And that intelligence wasn't just brilliance at the top, it was institutional. It was spread across many levels. It was reinforced through training programs, standardized procedures, and constant refinement. This is a key reason American weapons, even when not technically perfect, were consistently effective. The people using them were supported by a system that helped them learn and improve quickly. Training is where this begins. The United States entered the war with a relatively small peacetime army compared to the huge armies of Europe. When war demanded expansion, the U.S. had to turn millions of civilians into soldiers, sailors, pilots, and specialists. That transformation could have produced chaos. A rapidly expanded force often struggles with uneven quality. Units vary in training. Leaders vary in competence. Equipment is unfamiliar. Procedures are improvised. But the United States built training systems designed to handle scale. Camps, schools, and specialized training centers expanded dramatically. Training curricula were standardized. Manuals were written in enormous numbers. Procedures were taught repeatedly until they became routine. This standardization is one of the quiet strengths of the American approach. If you train large numbers of people in consistent methods, your force becomes more predictable and easier to coordinate. Predictability is not dull in war, it is powerful. It means units can integrate more smoothly. It means replacements can join units without being completely lost. It means commanders can expect certain baseline competence. This creates stability in operations, and stability allows momentum. Momentum is what unstoppable systems preserve. Another critical aspect of training is specialization. Modern war involves countless technical roles. Radio operators, mechanics, armorers, medics, engineers, artillery specialists, logistics personnel. The United States produced specialists at scale. This matters because specialists reduce friction. When equipment breaks, specialists repair it. When supply lines need organization, specialists manage them. When communications fail, specialists fix them. Every time a specialist solves a problem quickly, the war machine continues moving. And because the U.S. had the industrial capacity to equip these specialists properly, it created a force with depth. Depth means redundancy. It means problems do not cripple the system because the system has the people and tools to respond. This is a major reason American weapons became unstoppable. The American war machine was not thin, it was layered. It had support behind the support. It had systems behind systems. Training also shaped the American preference for combined arms. Combined arms is not simply having tanks, infantry, artillery, and aircraft. It's the ability to coordinate them so that they multiply each other's effectiveness. That coordination requires training. It requires doctrine. It requires communication. It requires planning. The United States devoted large effort to developing combined arms coordination. For example, artillery support was integrated with infantry movement. Air support was coordinated through forward observers and communications networks. Tank units worked with infantry. Engineering units supported advances by building bridges and clearing obstacles. When combined arms works well, it creates a sense of unstoppable force because the enemy is not facing isolated weapons. They are facing a coordinated system. If the enemy tries to stop infantry, artillery suppresses them. If the enemy tries to stop tanks, air power or artillery intervenes. If the enemy fortifies a position, engineers and artillery break it down. This coordination creates flexibility. Flexibility is one of the strongest advantages in war. A flexible force can respond to problems without collapsing. That is another marker of unstoppable power. Now, training alone does not create a learning machine. A learning machine also depends on feedback, and this is where the U.S. system became especially effective. Combat produces lessons. Every engagement reveals weaknesses. A piece of equipment that fails under certain conditions, a tactic that works poorly, a supply method that creates delays. The question is, what happens to those lessons? In some organizations, lessons stay local. Units learn, but the broader institution does not change quickly. In others, lessons are ignored due to bureaucracy or pride. The United States, over time, developed strong mechanisms for capturing lessons and spreading them. After-action reports, evaluations, and institutional analysis fed into training and doctrine updates. If a tactic needed refinement, manuals could be updated. If equipment needed adjustment, engineers could respond. If supply methods needed improvement, logistics planning could shift. This ability to convert experience into standardized improvement is incredibly powerful. It means the organization becomes smarter over time. And in a long war, becoming smarter is as valuable as becoming larger. One of the reasons this was possible is that the United States had strong institutional capacity. It had large staff organizations, training commands, logistics commands, and a culture of problem solving. American wartime culture often emphasized practical solutions over rigid tradition. This doesn't mean there weren't mistakes or resistance, there were, but the overall system was capable of adapting. For example, early in the war, the U.S. had to improve anti-submarine tactics in the Atlantic. It had to refine amphibious operations in the Pacific. It had to adapt to German defensive tactics in Europe. Each theatre created different demands. The American system responded by learning. It did not remain static, and because the U.S. could sustain operations while learning, it had time to improve without collapsing. That combination, endurance plus learning, is exceptionally powerful. Another part of this learning machine was the relationship between the field and industry. When combat revealed equipment problems, the U.S. could often respond with production changes. This is not easy. It requires communication between soldiers and engineers. It requires organizations capable of translating battlefield complaints into engineering requirements. It requires factories capable of making adjustments. But the U.S. had this capability. It could implement upgrades. It could refine designs. It could improve reliability. It could standardize improvements across production runs. This meant American weapons tended to evolve steadily. They became more effective and reliable over time. And because the U.S. produced so many weapons, even small improvements had large effects. If you improve an aircraft engine slightly, and that improvement applies to tens of thousands of engines, the effect on operational readiness is significant. If you improve an artillery, fuse, or communication procedure, the effect spreads quickly. This creates compounding advantages. Compounding is the quiet engine of unstoppable power. Another key advantage was logistics doctrine itself. The US didn't treat logistics as an afterthought. It treated it as a strategic priority. That attitude shaped everything. Logistics officers planned supply flow. Engineers built infrastructure. Transportation networks were coordinated. Ports were organized. Warehouses were managed. The US created systems to track and distribute supplies. It built depots. It built repair facilities. It created redundancy. This meant that when plans changed, as they often do in war, the supply system could adjust. An army without flexible logistics becomes fragile. It can be stopped by supply disruption. The US, by contrast, became increasingly resilient. And resilience is what unstoppable systems have. It means they can absorb shocks and keep functioning. Another part of doctrine and learning was the way the US handled replacements and unit rotation. War consumes personnel. Units lose soldiers. Crews are exhausted. Training pipelines must feed replacements. The U.S. developed systems to move replacements into units, to train them, and to maintain force levels. This system was not perfect, and it created challenges, but it was part of the broader learning machine. It allowed the U.S. to sustain manpower-intensive operations. And because manpower sustainability was paired with equipment sustainability, the U.S. could keep entire formations operational. A force becomes unstoppable when it can replace both people and machines faster than it loses them. Another often overlooked element is the American approach to coordination at the operational level. The U.S. invested heavily in staff, work, planning, and coordination. This meant operations could be executed with a high degree of organization. The movement of divisions, the scheduling of artillery, the management of supply, the coordination of airstrikes, all required planning. Planning reduces wasted effort. It reduces confusion. It increases efficiency. Efficiency preserves strength, and preserved strength allows sustained pressure. Sustained pressure is what unstoppable forces apply. This is one reason American campaigns often gained momentum once established. The system aligned, supply stabilized, coordination improved, and then operations could proceed with increasing effectiveness. Even setbacks were often followed by adaptation rather than collapse. Finally, there is a cultural element to this learning machine that can be stated calmly. The United States, as an industrial society, was accustomed to large organizations, production systems, and problem solving through engineering and management. That cultural habit influenced military organization. Problems were approached systematically. Solutions were standardized. Lessons were documented. Training was formalized. Improvements were spread. The war machine became not just large, but organized. And in a global industrial war, organization is a form of power equal to firepower. An organized force can apply firepower efficiently. A disorganized force wastes it. The United States, by building a learning machine of training, doctrine, feedback, and improvement, reduced waste and increased effectiveness. This is why American weapons, even when not always superior on paper, became consistently dominant in practice. They were wielded by an institution that learned how to use them better and better, and that institution had the industrial and logistical backing to support those lessons. So when we ask why America's World War II weapons became unstoppable, the answer is not a list of famous guns, tanks, and planes. It is the fact that those weapons belonged to a system that could learn at scale. It could train at scale. It could coordinate at scale. It could supply at scale. It could repair at scale. It could replace at scale. And because it could do all of that steadily, without collapsing, it produced a form of momentum that became very difficult to stop. In the end, unstoppable doesn't mean invincible. It means enduring. It means adaptive. It means renewable. And the American learning machine was exactly that, a renewable engine of improvement, turning experience into capability, and capability into steady, quiet victory. As we slowly come to the end of this story tonight, it's nice to step back and look at the question we started with in a simple, quiet way. Why did America's weapons in World War II become unstoppable? And after walking through rifles and machine guns, trucks and tanks, aircraft and ships, research and logistics, training and doctrine, the calm answer becomes almost gentle in its clarity. It wasn't one perfect rifle, one unbeatable tank, or one miracle invention. It wasn't a single moment where everything suddenly changed. It was something steadier than that, something that built over time like a tide that keeps rising. America's weapons became unstoppable because America built a system that could keep producing, keep supplying, keep repairing, and keep learning without running out of breath. Industry created scale, standardization reduced friction, mobility extended power across distance, and logistics ensured that the flow never truly stopped. Even the best weapon in the world can become useless if it can't be maintained, if it can't be supplied, if it can't be replaced, or if the people using it aren't trained to rely on it calmly and consistently. But the American war machine solved those problems one by one, not with dramatic flair, but with organization, repetition, and endurance. And in the long, exhausting rhythm of global war, endurance is one of the most powerful forces there is. The weapons themselves mattered, of course. The Garand's steady tempo in the hands of infantry, Browning machine guns, anchoring firepower across vehicles and ships, the jeep and the truck turning supply into motion, the Sherman tank representing reliability and replaceability, aircraft built and rebuilt in endless waves, backed by engines, fuel, spare parts, and crews, ships built faster than they could be sunk, fleets supplied at sea, islands reached and then sustained. And behind all of it, the quiet engine of science and training, the ability to solve problems and distribute solutions widely. All of those pieces came together into something larger than any single weapon, a predictable, renewable system that kept moving forward even when the war demanded everything. So as you settle deeper into rest, you can hold on to that main idea in the background of your mind. The unstoppable quality of American weapons wasn't only in how they fought, but in how they were supported, how they were built, delivered, repaired, and replaced, again and again, until the outcome became less about isolated moments and more about sustained momentum. And maybe that's one of the most interesting lessons of the era. Not that war is inevitable, or that force is the only answer, but that in modern conflict, systems matter. Quiet organization matters. Logistics matters. And the side that can endure calmly, steadily, often shapes the final result. If you made it all the way to the end of this video, I really appreciate you being here with me. And if you enjoyed what you heard, you're always welcome to subscribe so you can catch new calm war history videos every week.